not yet.
I'd like to thank my sponsor, Craig Wright.
Okay. Seems we are live. Let's check. Yes, we're live. Also, let me check the sound. Okay. Okay, it seems the sound is good because yesterday the sound was very low. Okay, we're live.
All right, we're live.
We did it.
We did it.
We have a nice voice
Oh, thanks.
for streams and
Yeah, I have
radio and so on.
Yeah, I've got a face for radio too.
Come on. Steve, thank you for joining, starting this second day of stream from the live desk at the BTC++. Privacy edition from Riga in the Bitcoin week. How do you like it, by the way? Is your first time in Riga?
Yeah, I'm really impressed by Riga. I didn't really know what to expect, but I was just texting my friends back home. This place feels like it was handcrafted by stone over 500 years. Everything is just, we're staying in we're in a very nice place of Riga right now, or Latvia, so I can't speak for everywhere, but this downtown area is just classic and beautiful.
It is, and yeah, you said for 500 years, maybe more.
Maybe more.
Maybe thousands.
Yeah.
But it's no, it's beautiful, and something I really like or I enjoy every time I come to Riga is that it's quite a small town. It's a city. It's the capital, of course, but it's quite small, so you can walk. Everything is walk distance, and
yeah, I couldn't believe when someone said that there was only 600,000 people here. Because the amount of infrastructure and buildings and just it seems like the amount of wealth and capital that went into creating all this stuff just seems like a city of 5-10 million people. It just seems so big and nice for being so small.
And the infrastructures, everything, the bridges, it's amazing.
Yeah.
So, aside of our opinion about Riga, you had a talk yesterday that I missed because I was here.
Oh, how dare you.
But it's good because then I can invite you here.
Right.
And then you can explain me a bit more.
Yeah.
So what were you talking about?
So my project that I've been working on in my free time for the past 6 or 7 years now is called UTXO Oracle.
That long?
Man, it's been longer.
Yeah?
Well, I've been just being a UTXO blockchain archaeologist ever since I got into Bitcoin. My website, utxo.live, it shows heat maps of Bitcoin transactions all day, and I like to look at the historical patterns of how people spend UTXOs. And I noticed about 6 years ago that it was pretty obvious to see what the price of Bitcoin was just by looking at the spending patterns and behaviors. And I was like, somebody should make a price oracle that just gets the fiat price directly from the chain. And then, of course, when you have an idea like that, you have to do it because nobody else is going to do it. So I've made a open source program that runs directly on your node and does some statistical calculations looking at clusters. Turns out the major clusters on Bitcoin on chain are for round amounts of USD. This happened primarily because wallet apps give you the option, and a lot of times it's the default option in the US of just denominating your transaction in a US dollar amount instead of Bitcoin. It's very clear when this started happening, around 2016, 2017. It was like a switch going off. Most everyone sent round amounts of Bitcoin before that. People sent 0.1 Bitcoin in the early days, and then it was 0.01. And then it just transitioned to people spending round amounts of dollars instead of round amounts of Bitcoin. We're never going to stop people sending round amounts. Like 90% of transactions are either round amounts of fiat or round amounts of dollars, just because the tickets for the Honey Badger conference tomorrow are €250. I mean, even the most OG cypherpunk Bitcoiners in the world, we still price things in round amounts, just a natural human tendency. So anyway, so I can identify these round amounts of fiat clusters on chain, and from there I can reverse engineer the price.
I mean, it's an interesting topic, and I believe that this comes and goes from time to time. This conversation about the unit of account should be Bitcoin, and these Bitcoin events should charge in Bitcoin, but yeah, volatility doesn't allow that, and that's why I understand that conferences, they establish a price in euros, dollars, and then you can pay in Bitcoin, but it adapts to the.
Well, I mean, I don't really care. I mean, even if they charged charged in Bitcoin or set the price in Bitcoin, it wouldn't have 8 decimals.
No.
It would be 0.002. You know, it wouldn't be a long string of random numbers.
Yeah.
But like you said, yeah, for volatility or whatever, Bitcoin's purchasing power just keeps going up and up. And so what we see on chain over time is that if you look at the average size, average transaction amount of a Bitcoin transaction, it just goes steady down. So like if I were to what I do is I look at kind of all the transactions of the entire day. I look at the bell curve, and I'm like, where's the middle of the bell curve? Middle of that bell curve was around 0.1 Bitcoin in 2016. 2021 or 2019 or so, the middle of that bell curve was 0.01 Bitcoin. Now the middle of that bell curve is 0.001 Bitcoin.
So 100,000 sats.
Yeah, and so it's not just the round amounts of dollars. It's like all of the statistics, they just go down very naturally, and they go down naturally according to purchasing power. And so I think that's really powerful that Bitcoin is a record of human activity, and it's specifically a record of the purchasing power of Bitcoin when you look at it from a macro economic statistics. Yeah, that was my talk was about, first of all, finding the price of Bitcoin, but second of all, like what does the blockchain statistics tell us about like humanity, like how we spend? And tomorrow at Honey Badger, I'm actually going to be talking about time cycles, like times of the day, days of the week, different months of the year. You can sort of predict what time it is on Earth just by looking at the Bitcoin transactions.
But related. This is very interesting. But related with this, could we say that Bitcoin, because of its activity, is more Western, is more Asian, is more, it is related to, because the world doesn't stop. There is always an activity moment for every part of the Earth. So could you also learn that from checking the...
Yeah, right now, most of the activity occurs around 3 p.m. in London time.
Okay.
So it's certainly centered over Europe and America, kind of morning in America and Europe in the afternoon. I think that's just where most of the people have the economic freedom and the capital to kind of get into Bitcoin and move lots of money around. So it's not so much reflective of where people live, because I think most people live in India and China, right? But I guess like the most ease of access and flow of capital into Bitcoin definitely happens in Europe and America. So we don't have to worry about China banning Bitcoin, because it's not that much activity anyway.
Yeah, no, they achieve it after so many years banning it.
China banned Bitcoin.
Yeah. No, but okay, just as a recap, This the first time I saw your project. I was like, oh wow, this is even possible. So basically, the idea is that you don't have to ask an exchange, what's the price of Bitcoin now, because just by checking the transactions that you have on your mempool on your blockchain. No, I suppose it's more mempool, no? So, or the just mine. What are the most important ones to define the? I suppose also it's not instant. It's based on how many hours average is one price per day. How does it work?
Yeah, so UTXO Oracle is kind of like Bitcoin in that it's kind of a soft consensus statistical kind of program. So the longer time you give it to do an average, the more accurate the price will be.
Okay.
A day is about how much you need to be like 99% sure that you're going to get a good price. So on my website, I have done every day since 2020, and it's perfect. It gets the exact. I mean, in a way, when people ask me like, "Is this close to how accurate is this to like the price?" I ask, what is the price? I think in the long run, the on-chain price should probably be the reference price. Well, I mean, whether it's UTX Oracle or something else, the fact that the price is on-chain is independent of anything I do. You just look and see if you look in the right way, and I think that should probably be the price. And then other exchanges are compared to that.
So you haven't calculated a deviation, let's say in averages.
Oh yeah, I've done it. It's right in the middle because different exchanges are different. There's open price, closed price, high price, low price, and there's probably 10 or 15 different exchanges that all have slightly different numbers. UTX Oracle is just right in the middle of all of them. It's indistinguishable from any particular exchange.
Have you had any day in which UTXO Oracle went nuts?
Yeah, well, there was in the early times. I feel like it's getting better and better. Every year I improve it. When inscriptions first started coming in 2023, I was not ready for that. So inscriptions significantly changed the behavior of transactions. Half of all transactions were now inscriptions. And so I had to deal with just the remaining half of the transactions, and I had to find a way to filter them out.
Okay, so you had to find a way to identify them and not include in the calculation, something like that.
Yeah, I don't know if people want to hear this, but if I just don't include Taproot transactions, any Taproot.
Just to avoid all that.
Yeah, so for every one Taproot transaction that has price information in it, there's 1,000 Taproot transactions that have nothing but JPEGs. So, I mean, one person's noise is another person's treasure. I get it. But for UTX Oracle, I don't use any Taproot. So I remove Taproot. I remove round amounts of Bitcoin that are clear. I remove op returns. The transactions that have, this is kind of cool in a way, like the transactions that have the best price information for me are peer-to-peer. So just if there's a transaction, it's pretty clear that this is one person sending to another person because there's only 1, 2, 3 inputs maybe, and there's only 2 outputs. It's pretty clear that this is a transaction that's P2P. And those are the transactions that are almost always have price information in them.
This is after I saw the project, I started to read about it and understand what you had to do to be able to recognize these patterns of transactions and price. I think that the interesting part is that you had to draw those lines, no? There is these graphs that you have, I suppose it, because I am speaking by memory, and I checked it maybe a year ago. So in your website, I think you have these graphs, and then there are some lines there which you identify for example, the $1 value, no? Or the 100 value. I remember it was something like that. So I suppose this was the first step.
Yeah, well, it was more than the first step. I didn't even have the idea until I saw the lines in the charts. So When I was doing my PhD, I became very good at data visualization of really massive heat maps in Python. I was working with satellite data of the temperature of the ocean.
Okay.
So for like 5 years, I was making heat maps of how the ocean currents move around, like temperature and heat, and me and my professor were trying to understand how heat moves around in the ocean in very kind of chaotic waves. And so I, got good at Python and data visualization, and then Bitcoin arrived, and
And that was the wave. That was
and
the
that was the
tsunami for
wave.
you.
And I was like, all of a sudden, I can't think about the ocean anymore. Like all I want to think about is Bitcoin. And so then I used my, Python data visualization skills to just make maps of what the activity on the blockchain. And then so I made those maps first, and then I was just like, wait, what's this? And I was like, why is there this line here, and then why are there like 30 lines all parallel together, but they all move a little bit in concert every day up and down? And I'm like, oh, this is people sending round amounts of dollars. And, then I was like, someone should make an Oracle out of that.
And then there's something, because I always saw your project, I'm really interested about these findings that you did, but I never set it up. But I always thought like, okay, how it would work? Like, is it fully autonomous? So if I install it in my node, let's say, then it would like keep on going unless there is the patterns get broken, it will keep on capturing or finding the right price, or it needs to keep on being fine-tuned constantly by you?
Oh, no, definitely not fine-tuned constantly by me. So it's released now. I have a very kind of simple programming style. So it's just one Python file. You can just download it with one command, and then it just runs with one command also. There's no third-party installations, so you don't have to do pip install or anything like that. Just simple Python script. I don't have it set up to continuously run right now, though I could do that fairly easily. I've decided to build kind of modularly, where I just have like one thing that works, where it's just find the price of the day. And so that's what works right now, and you can run it for yesterday. You can run it in historical mode, and you can run it up to the most recent confirmed block.
Okay.
I haven't implemented continually running yet. I'll probably first do that in the command window. So you just have a command window where it keeps running. But as soon as you start thinking about like graphical user interfaces, right now it serves an HTML. It writes a local HTML file, and then it launches that HTML file in the browser, which shows the chart of the day. To make it continually running.
Even if it's updated once per day. Even
Oh
if,
yeah, yeah. I don't want. Oh yeah. Well, you can just click run every day.
yeah, no,
Yeah.
I was thinking something like, we have this node implementation, I don't know how to say it, or operating system, node operating system, Umbrel, Start9, and I kind of imagine just installing UTXO Oracle there, and just having even an onion that I can access from anywhere and check what is my node telling me about the price from yesterday, something like that. Is that in the roadmap, or?
Oh yeah, it is. I mean, I've had 2 misstarts with Start9 so far. A couple of the devs that I was working with to help me with that. I'm at the point now where I kind of need some people to help me doing all the implementations for the different node products. Start9, it's in the works, but both of the devs that have helped me with Start9 have said that they don't really want to do anything further until Start9 releases their 4.0 operating system. Have you heard about this?
Yes.
And there seems to be a lot of delays with that. Is
Yes.
that right? And so we're kind of stalled because nobody wants to push the product on the old operating system.
With an umbrella.
With the Umbrel, it sounds like they're at least not, they don't have that problem. And I did start working with somebody at Umbrel before I had to get ready to go to this conference. So, yeah, I mean, if that's what people, if that's how people are running their node, then I want to help them to be able to see it. Yeah.
Yeah, because it's easy for most of us, and I know that running a Python script is not complicated, but it's convenient to know that you have always the service available, and you don't have to manually do it. Just access, and from now, for example, here is my computer, and I could access my nodes and check many of the services they have. And I have both Umbrella Star9, and this is what I would love to have, that I can access my price oracle from my node,
Yeah.
not asking anyone, not asking Kraken, not asking any exchange,
Yeah.
and that's amazing.
Yeah, I think it's really, it kind of completes, I feel like one by one the community is just cutting out more and more third parties, cutting out more and more surveillance. So yeah, this is just another one of those.
Yeah. You said that yesterday you explained your project, but also you explained what you learned from looking at that data. Which were the things that surprised you the most in your studies of the price action in the blockchain?
Well, price, I mean,
All right.
not so much price, but like just transactions.
Yes.
People spend for crazy reasons. So when I'm watching the chain, everyone knows that, they hear about some big deal like inscriptions or something like that, or somebody sending too many op returns right now. But the chain is the Wild West. There's robots, they do things like they send transactions continuously and they increase 1 Satoshi in each transaction for like 3 days.
Like
Like they go from the 10,000, then 10,001, 10,002, and 10,003, and they just keep doing this. And then they keep going back down. And it's just like, why is somebody doing that? And then there'll be something completely different. Like there's this one wallet, I think it was a DeFi wallet, that had a hot wallet of 10,000 Bitcoin. So billions of dollars, hundreds of billions of dollars. Every day they destroyed their UTXO and created a new one. With $100 billion UTXO. Yeah, like, and the more you zoom in, the more you just see like the strangest behavior.
but for no reason, just moving, just like a self sending.
I think that
One input, one output.
I think this was a major DeFi project who, the way they worked is every time somebody made a deposit or a withdrawal, they destroyed their entire stash and
The whole coin.
and recreated it. Like, let me withdraw $10. Okay, burn the $10 billion Bitcoin UTXO minus $10 and recreate the change. This was happening for like 2 years. That was wild. Mostly just the surprising thing to me is just how well the statistical distribution just tracks purchasing power. It really is a record of, we're in this great war between Bitcoin and fiat, and it's pretty clear now that Bitcoin's not just a fighter in this war; it's also like the scorekeeper.
Yeah.
It's showing you how much little Bitcoin you need each year. Each year, the amount of Bitcoin people need to live goes down, and you can see that on chain very clearly.
Which is the area that is more used in value? Which are the transactions that are more common?
Yeah, so if you think about the bell curve and you think about from like 10% to 90% of transactions, those transactions happen between 10,000 satoshis, up a power of 10 to 0.001, which is $100, up a power of 10 to 0.01, which is $1,000. That is 90% of transactions.
So between $10 to $1,000.
Between $10 to $1,000 is where like 90% of transactions occur. Yeah.
And this is what where you get the most information to price the Bitcoin during the day.
Yeah, well, that's where I get the most information, or all the information. I don't use values less than $10 or more than $1,000.
What about other currencies? What about euro, for example?
Yeah, so I'm not like proud of the U.S. dollar or anything, and I was very surprised to not see much evidence of other currencies, which it doesn't make a lot of sense to me. When this is hard to talk about without seeing the charts, but when you look at the data, it's just like all of these things are perfectly correlated. I mean, it's not like, so the euro and the USD, their exchange rate has changed by 20% this year. And like over the past 5 years, they've fluctuated up and down 20%. So all the lines I see are just so perfectly correlated. They don't change by 20% from one another. So I haven't been able to find euro in there. One thing I do is I remove the round Bitcoin amounts before I do this. So I could do a third step, and I could remove round Bitcoin and then remove all round US dollars, and then I could see what's left over.
That would be amazing.
Yeah, I could,
to identify
I could try to
activity
do that,
in
yeah.
other currencies. I don't know, maybe we would find
Yeah.
the Brazilian real or the Argentinian pesos. It
Yeah.
would be interesting to see what is the second most used unit of account in
Yeah,
Bitcoin.
it definitely would. Yeah, it's fascinating stuff you can see there. I think one thing that made me curious was like, okay, maybe this is Tether, or because honestly, I was like, man, this many $100 transactions. I mean, I was like, I know people get gift cards. I know people withdraw from the ATM. I know friends sending presents to each other send exactly $100, but like really 10% of all Bitcoin transactions are $100. Can you believe that? Like 10% of all Bitcoin transactions are exactly $100. That just seems like way too many. And I was like, is there something going on with Tether or stablecoin?
In what way?
I don't know. Like people trading Tether for Bitcoin somewhere, and they just happen to trade it for even $100 in Tether.
Maybe peer-to-peer buys, gift cards.
That's the only reason I could think for why U.S. dollar would be so much stronger than any other currency. I mean, I know it's going to be a little bit stronger, but I didn't think it was going to be like, just completely dominate the signal. But yeah, it's still on my roadmap to look for other currencies for sure.
That would be interesting to know. And also, of course, there is lining, and there are things that you cannot see there. Mm-hmm. But I'm curious to know if now there has been some conversation about the mempool being empty, or that the blocks not being so full. Mm-hmm. I suppose that as you look in time frames of 24 hours, I suppose this is like not a big deal for you.
Yeah, it's not a big deal for me. Not only do I look for 24-hour time frames, I also just do the percentage of the daily total. So if we have a day with a lot of transactions, or we have a day with no transactions, in my equation, I just divide by the total number of transactions. So I just look at the percent, like this 5% of transactions were at $100, and so as long as I have, we have a typical day, we have like 500,000 outputs. So even a light day on Bitcoin would be hundreds of thousands of transactions.
Now it came to me that the moment that we had the inscriptions, we had a backlog of transactions, a huge backlog. I don't know how many hundreds of logs were waiting to be mined at some point.
Yeah.
But I suppose that People who is really interested in transacting in dollar-denominated movements of Bitcoin, they are interested in getting in the next block, no, or in the next couple of blocks.
Yeah.
So this delay of hundreds of blocks affected the calculation, or not really because of what I just said?
Not really because of what you just said for, days like that you're talking about, but it does happen in the short term. So one thing that is not open source that I'm kind of working on and haven't released yet is the mempool UTXO Oracle.
Okay.
So I have a live streaming price of the mempool UTXO Oracle.
Okay.
It's on a YouTube channel. It's
Yeah.
not open source yet, but and it's pretty good. Like, I mean, of course, it's not always perfect, but 90% of the time, the price is on the mempool. And what interesting that happens in the mempool is if there's a mempool spike in the middle of the day
Yeah.
and you get really unlucky and you put your $100 transaction in and then the spike goes up and you get stuck in the mempool, well, the price that you thought it was in the morning, it gets delayed until the afternoon. So then UTXO Oracle is confused by what the price is in the afternoon. So yeah, that happens. But that's just, I don't know, it's just kind of cool. So the price, instead of being one solid line, it's kind of like spread out. And the price being spread out also happens when two different exchanges have two different prices.
Okay.
And so when I'm looking at the price line, whether the line is thin or the line is thick, it's just either some uncertainty in exchange prices around the world, or it's uncertainty in the mempool fee market. So it's some measure of like something different going on.
Yeah, because at the end, maybe you don't check any other exchange. You just check the blockchain. But wallets, when they send transactions, they're checking exchange.
Right.
So at the end, you get whatever difference they have in the price. You are seeing that later on the blockchain. That's
Right.
interesting.
And it's not too much later on, especially in the mempool. The mempool price changes right when the exchange price changes. It's very fast, maybe a couple seconds different. And yeah, I'm not doing the averaging. The people of the world making the transactions, they're doing the averaging for me, right? So they're getting, when they make a transaction, they're getting the price they need from whatever exchange they need, from whatever their wallet uses on the back end. Wallets use different exchanges. So it's already averaging all the exchanges. And it's also selecting the group of people in the world that know how to make an on-chain Bitcoin transaction. So the way it averages over all exchanges, and it's not just using anybody, it's only using people who know how to use on-chain transactions. So it's a really nice average. Yeah, so like some billionaire Wall Street guy that goes to Coinbase and puts $1 billion in the order book, but has no idea what the chain is, like that price is not going to show up on the Oracle. I mean, it maybe later on in a way it might show up because he might affect the Coinbase price, and the Coinbase price might affect this later on, but immediately, like some flash crash or something, probably won't show up on the Oracle.
It's so interesting, and again, when I keep on talking with you and keep on thinking about possibilities and information you can get from there, it's amazing because all these the people who enjoys Austrian economics and we talk about human action.
Yeah.
Basically,
human action.
Basically, it's human action, no?
Yeah, I love that.
And you can read human action live.
Oh, wow.
Every moment from mempool, and then
Yeah.
crystallize in blockchain, and then extract information from there.
Yeah, you just gave me an idea. So my talk tomorrow, I titled "Record of Human Economic Activity." Maybe I should trigger everyone and say "Record of Human Action."
Yeah, yeah, in a way, yeah.
I mean, it is in a way.
It's of course we don't do everything with Bitcoin.
Yeah.
It's a part of our economic activity, but it's human action, definitely.
Yeah, it is. I mean, Austrian economics changed my life. I mean,
Was it
Can't believe how old I was until I started thinking about what is money, and then realizing, Bitcoin. So I got into Bitcoin through more of technical, and a little bit, 2008. So I knew something was wrong with the money, right?
Mm-hmm.
So I was like, something's wrong with the money. All right, what's this Bitcoin thing? But man, yeah, it's Austrian economics, and now everything makes sense. So just the same story you always hear. Yeah.
Yeah, so it was first then Bitcoin and after Austrian economics for you?
Yeah, I didn't care about money before. I had kind of a liberal upbringing, and I thought money was the root of all evil.
Yeah.
I was the typical. I hated corporations, and therefore I hated capitalism, and I had all that stuff confused before.
Yeah, Bitcoin
Yeah.
is amazing how it fixes many things in one's life once
Yeah.
it enters. Steve, thank you very much for joining.
Yeah.
It was a amazing conversation. Again, I think we could keep going because the whole possibilities by looking at this human action, for example, or checking if Bitcoin uses more dollars, or maybe what is the second best fiat currency in Bitcoin, or the second most used one. That's
There's
also
no second best. It's just Bitcoin.
exactly. But yeah, thank you for coming, and I'll definitely keep an eye on everything you do. And I look forward to see it in Umbrel and Start9 whenever this version 0.4 comes out finally.
Sure. Yeah, thanks. I can't wait to make it. And I also can't wait until it goes away when US dollar price is not relevant anymore.
Yeah, I don't know.
One day.
One day, I don't know if we will see it.
I don't know if we'll see it.
But at least we will be able to check it in our notes.
Right. Yeah.
Thank you.
Yeah.
So now I'm gonna go kidnap someone. It got quite quiet now. I
Yeah,
thought
they all come at you at once.
maybe
in
because
between
there
the
is a
talks.
hackathon finals or something like that. I don't know. But yeah.
Well, Super Testnet, I think, will probably come next after he gets out.
Yeah.
Yeah.
And also, yeah, we have many people to join today. Kale also is coming in a bit. So yeah, I'll jump for a moment, look for someone.
All right. Do you
I'll
keep
be
it
back.
running, or you stop it in between?
No, it keeps on running. So
Just
this
keeps
is
on running?
this is a live desk.
Okay.
So now we're live from Bitcoin Plus Plus, and it's gonna be live until I finish it.
Okay.
So we're gonna be here for 2 hours more, 3
Oh,
hours
I
more.
see. Okay. All right. So it's just gonna keep
The
running.
open house. Yeah.
Nice.
I mean, with some filters, like you with Taproot transactions, you know.
Yeah.
Okay, Steve.
All right.
So
Yeah.
thank you
Thanks
for
having
joining
me.
Yeah. I'll be back.
Us Bitcoiners, we can talk forever.
Yeah.
Thanks. Very good questions.
No,
I
I-
really appreciate it. Yeah.
Enjoying a lot.
Yeah.
You start again?
I'm working with Start9 to try to.
I'm waiting for the new release to come out.
Oh, the Oracle? Yeah.
I want to build I want to wrap an app and start night, but I'm kind of waiting just in case stuff changes to like actually, I think they use Podman, those Docker type stuff. I'm waiting till the new release until I try to wrap my app up into Start9.
Okay, sure. Okay, so our next guest is coming soon. And now there is a break of something, and people is coming. So, wanna join? We're live now. Come, join. Somebody, get this. Yeah, come here, but help me with that chair because I'm putting it next because somebody will be joining also. So we will be 3 of us now.
Amazing.
Get closer. So we fit all of us. Okay. So you don't need a lot of introduction, but it's for you.
Thank you.
Do you want to introduce yourself?
Yeah, I can do that. My name
Can you?
is. I can try.
Okay.
So my name is Michael. I'm the co-founder and CTO of Bolt, and we are doing submarine swaps between the Bitcoin layers, between main chain, Liquid, Rootstock, and Lightning.
It's a service we love, a service I use a lot to jump from Lightning to Liquid to on-chain and so on, and also Rootstock. And yeah, as it works so good, at least from a user perspective, we can see some UI things here and there, and we kindly report them as fast
Yes.
as we see them, very patiently.
And they will all get fixed eventually. It's a question of when.
Yeah,
Not if.
no, but amazing team, I have to say, and no joking here.
Thank you.
But when everything works so good, do you still have to do something in Balls or
Yes, there are
just
actually things to do, you know.
there
are many things
You're
to
always
do.
on holidays. Asking.
It's really the other way around. Like, especially with Lightning, there is so much operational effort going on behind the scenes because you can't have your Lightning node offline ever. It has to be online 24/7. You can't ever lose state of your channels, else your money is gone. And you have to make sure your liquidity is in the right places so that people can pay you and you pay them. So pretty much if you see some Lightning service running nicely, there is some guy sweating bullets to make it work behind the scenes.
I thought it was the node just working. So no, you have to be
It's like actually effort, especially for Lightning. It's a lot of effort.
an everyday effort.
An everyday effort. An everyday effort. You can't have like 1 day of downtime because if your big node is like down for more than, let's say, 5, 6, 8 hours, you're gonna have a huge problem at your hands of like a bunch of force closed channels, and Lightning does not forgive at all.
I remember when we had inscriptions coming. Yeah, that was
Yeah, and also those times, they screw you over big time, and you have to make sure to reconfigure your node, to not go crazy with the fees, and kind of hold on enforcement transactions, to not spend thousands of dollars on your channel closers.
Is it still complicated now that the mempool is super calm? Is it still complicated?
It makes
or-
things easier. It doesn't fix the inherent operational efforts of Lightning, but it makes things easier and more relaxed. Because during the ordinal craze, we had a couple of nasty channel force closures, and they cost us hundreds, if not thousands of dollars. So it was nasty, but the current fee environment makes things more relaxed in this aspect.
Yesterday we met. We had a dinner with some other Bitcoiners, and somebody asked you what I found was an interesting question. That it was if you could explain blinded paths easy and fast. I'm gonna go and get there, but I'm asking you this because one of the last new flashy things that you have in Bolts, I don't know since how long ago.
Couple months.
Couple
I
of
think.
months,
I
but
I think I know where you're going.
It's Bolt 12, no?
Yes.
Okay.
All 12 support in our swaps. We do have now.
Okay. First of all, what is Bolt 12?
So
What support do you give to Bolt 12?
It's all right. Maybe let's start from the beginning, like a quick explainer, real life 5. What is Bolt 12?
Yes.
Because it's a term that's thrown around a lot. So let's put it a little bit in context. In Lightning, we have the so-called Bolt specs. They specify what is Lightning even. And we have, like everyone knows the Lightning invoices, the LNBC thingies. And those are called Bolt 11 invoices because they are specified in the Bolt specification number 11. And Bolt 12 is, as the name I guess indicates, the next version of Lightning invoicing format, where it focuses on the issues that we've seen with Bolt 11 in the past. Namely, like these recurring payments and not having to generate and send out of band some new invoice for every time I want to pay you.
Okay.
And this is the thing we call offers. So you give me a way to reach, for my node to reach out to yours, to ask for an invoice behind the scenes. And I can just pay to your offer from a UX perspective without having to text you, could you send me an invoice for 5,000 sats? My node asks you to please give me an invoice for 5,000 sats and directly pay it.
Does it work though like LNURL that it's asking nevertheless an invoice?
Yes, it still asks for an invoice behind the scenes.
So we're still using nevertheless Bolt 11 invoices.
No, it's a new kind of invoice. It's a new kind of invoice,
Okay.
but the concept still transfers over.
But at the end is a way to communicate between two nodes.
Exactly.
And at some point when they find each other through the Lightning network, there
Yeah.
is no outside,
No out
outbound,
of band,
Yeah,
exactly.
out of band.
That's the main intention with those reusable Bolt 12 offers, that you don't have to do LN URL anymore, don't have to set up an HTTP server, don't have to like do an extra like whole different protocol that's outside of the Lightning spec to make this work. You can just have it all in spec and work just with your node, no other software needed, out of the box. That's the whole, one of the main intentions behind Bolt 12.
And Bolt 12 is again a long string of tags that you can simplify by again using BIP 353.
Exactly, yeah.
Domain names.
Exactly. To put your BIP21 with a question mark LNO equals your Lightning offer into that TXT record of your domain server in a special place, where you just like put down there, for this domain, this user at this domain has this BIP21, well, let's just fetch that and detect, hey, this guy can be paid on Lightning and this is the offer. Fetch an invoice for it and can just pay you. And I think it's a pretty nice system. It's a pretty dandy one. I like it a lot.
So, this is what we have now that we can use, as we are very used to with Lightning addresses.
Yeah.
We can have something that looks like an email, but it can be a Lightning address or it can be a Bolt 12.
Or a BIP353, they look the same. Like if I tell you Michael at Bolt's Exchange, it could be either an LN URL or BIP353.
So it can have an offer under.
It could be both. It could be both.
Could be both?
Could be both, yeah.
Could you have the same email address?
Yes, you actually can.
And
Misty
who resolves? Who resolves what is what?
Like for example, Misty Breeze does it. If
Okay.
you have your @breeze.fun, LN URL and BIP353, it is both. Because they're different protocols. BIP353 lives in the DNS record, while LN URL is HTTP. And
Yeah.
they don't interfere with each other. You can have both at the same place. Which one resolves is up to the client. The one that pays, what do they support, and which way do they fetch? And if they fetch both, which one do they prefer?
Okay.
It's up to the client. Like our web app does fetch both and picks. It prefers BIP353 and Bolt 12 offers, but if there is no offer and it's just a LN URL, it resolves the LN URL just fine too.
Okay. Okay. Then, now that we know this,
All right.
how
Little
was
bit of a sigh of a.
Yeah, well, amazing. But how this then goes to bolts? How did you implement it, Bolt 12
Yeah.
in bolts?
So we allow you to pay Lightning invoices with bringing out main chain payment, liquid payment, RSK transaction. And this used to be only Bolt 11 invoices you could pay. Now you can also give us Bolt 12 invoices. And we're going to pay them just fine. And also the other way around. You can create an offer in your Bolt's API client, register that offer with us, and you can receive Lightning payments to this offer, and it's all swapped to whichever chain you prefer.
Oh, okay. So
Yeah.
I can register in bolts. I can create like a payment gate.
Yeah, exactly, yeah. It's like a gateway, that we are your gateway to the Lightning Network, and whenever someone requests an invoice for you or tries to pay you to your offer, we just call on you like, hey, please give me an invoice to give to the payer, or hey, your swap is ready to be claimed. And we are pretty much your gateway to talk to the Lightning Network.
So then you can get payments of any kind of Bitcoin flavor
Exactly.
and receive it in Lightning
Yeah, exactly.
through this gateway.
Yeah.
Oh my god. Okay, that sounds very good. But just before I let you go, this is the privacy edition of Bitcoin Plus Pass. So I have to go back to blinded paths. because there is some connection, no? Bolt 12, blinded paths, and they should bring some privacy. Do we get some of this privacy also in bolts with this implementation, or nah?
Kinda, partially.
Okay.
Because how about we talk briefly about what blinded paths are?
I love it.
I'm a little bit fuzzy on the details myself because it's a very complex specification. But the basic idea is, let's say you give me a Bolt 11 invoice.
Okay.
I know who signed that invoice. That is the destination.
So if I do you with my note,
Exactly. If you
an
give me a
invoice,
Bolt 11 invoice, I know that's Luna that I'm paying. I know who you are.
Yeah.
I know your pub key. I can see your public channels if you have any.
Yeah.
I see your whatever public information you tell the Lightning Network about your node. Which is not that great privacy-wise, because you pretty much have an easy way to identify nodes. You see them every time. They use the same public key every time when you sign invoices. There is ways to trick around that, but they are all pretty hacky and not built into the protocol. So what blinded paths are, that instead of showing I am the one who signed the invoice, that's me, hello, you basically
you wrap it.
In a sense, you basically pick one of your channel peers, or even someone like 2 hops away, and encrypt who you are and how to get to you with their public key.
Okay.
So basically, instead of telling me, hey, I'm Luna's node, please pay me, you're telling people that, hey, if you want to pay this invoice, go to this guy over there, and they will know how to reach me. And the nice part is that you can just switch people to talk to reach you. For if you send me an invoice, you let me talk to some guy over there. If you send someone else an invoice, you do a different blinded path, which means that who actually is sending those invoices and who is getting paid, that's not exactly clear. You can just obfuscate your trade a little bit and have a hop in between that you trust and rely on for your privacy. And you don't have to dox yourself fully for being paid by random people.
Is it a little bit like what LM Proxy was doing?
In a sense, yes. Like LM Proxy, but properly specified and nicely supported
as a protocol
and built into the Lightning node itself without having to use some proxy wrapping service.
Okay. That's great. Then do we get some of these benefits now in bolts, or not?
When you give us a Lightning, a Bolt 12 invoice to pay, we can pay 2 blinded paths just fine, that we support. If you receive via your Bolt 12 offer that's registered via us, you can, we don't restrict on what you do with it. If you want to use a blinded path, that people reach us via blinded path, you can do that. That's going to be just fine.
So we can hide a bit from your observation.
In the end, not from our observation, because in the end it's a swap through us, but you can make us not know who exactly it is you're paying to with your swap, and you can, people that you show your Bolt 12 offer that's registered via us, you can make them not obvious for the payer that it's a swap, and have a blinded hop in there that they reach us.
You can get a better privacy in general.
Better privacy, in the end, we're not a privacy tool. That's not what we focus on. But those Bolt 12 privacy benefits are so ingrained in the protocol specification that you just get it as a freebie, basically. If always when you use Bolt 12, it's a little bit more private because it's just the way the spec was written.
It's amazing, and thank you very much for the explanation, because I feel that today was even better than yesterday. Today it got easier, and no, it's great again to have bolts because it's amazing, and also everything that enabled, no, since you started doing the plugin for BTC Pay and so on. So yeah, it's great. Keep on making it look like you do nothing, but you do.
Yeah, that's the art of it, isn't it? To make it look easy.
Yes. So keep on doing that, and thank you for joining.
Thank you for having me.
Yeah. Oh, you can give me the honey also. Okay. So yeah, now everybody's here. So I'm gonna go grab someone else. They are eating. It's lunchtime here. I should also grab something for me. But no, I will just go try to disturb someone. Bring here. I think that the audio today is better, which makes me really happy because yesterday we had some issues with it. You had to max out your computer volume, your phone volume to hear it. But today, yeah, no, it seems we're good. If not, let me know because I can still. Today I know how to tune it a bit. So yeah, I'll be, or I think that yeah, next guest is coming. Yeah, great. I'll reassemble this. Hi. Thank you. Yeah. Before I prepare, if you also wanted to join, but it's great.
Oh, sorry. Okay.
No problem.
All right.
So, I will ask you first for an introduction and about what you do.
Okay. Yeah. I'm Aryan. I work on Tollgate, and I rolled into the space through Noster,
Oh,
basically. Yeah.
okay. What do you do? Because you had yesterday a talk, no, or it's today?
Just this morning.
Just this
We had a
morning. Okay.
workshop, Yeah.
Okay. And what do you do? What's the idea?
So Tollgate is a protocol we're developing, and we're developing the first implementation for it that enables anyone with any hardware that has a LAN port or a radio,
Okay.
Wi-Fi radio, or even cellular,
Okay.
to become an ISP. So every individual that owns any of that hardware can buy and sell internet access. So
Okay.
instead of there being like one big entity that provides it all the way top down, we do it bottom up. And we do that through micropayments with eCash. So anyone that wants to use internet would pay with eCash, small recurring payments, and that would trickle up to the people that are providing the service, and they would be competing for their customers.
Okay. I need a bit of.
Let's dissect.
Yeah. Let's. Okay. I am the one. I have a computer. This computer doesn't have a LAN now, but it has Wi-Fi. So, how do I relate with Tollgate? How?
So in our current implementation, what we make is a captive portal solution, which works like when you're at an airport, for example, right? You select the Wi-Fi, you get that pop-up.
Yeah.
So what we do here is we make this pop-up where you can paste eCash, and you get a certain amount of minutes for that. So say I have 20 sets of eCash, and it will say that 20 sets will get you half an hour of access.
Okay, but how do I connect, or how do we? Because who am I? I am the one consuming, or I am the one.
In this case, you would be the consumer, like the end consumer of this network.
Okay, and for that I need to connect somewhere.
Yeah, to a Tollgate Wi-Fi hotspot.
Okay, and this there is because I believe that then whoever could be provider of Tollgate, or how?
Yeah, anyone can become a provider.
So my neighbor, for example.
Yeah.
My neighbor, flat next to mine.
Great example. Yeah.
Is a provider. Then I see the Wi-Fi. I
Yeah.
see that he's offering that, and well, it's close to me, so I can consume it.
Yeah.
Then I would just ask to join. Normal.
Yeah, it's an open Wi-Fi network, so you would just connect, and then you get the pop-up to make a payment, and this is one way to pay with your phone or your laptop, but obviously you're probably going to have a bunch of devices in your home, right? You might have a fridge, TV, smart TV. You're not going to do that everywhere. You're not going to do it every so many seconds. So this is just a first implementation for us to demo the ability. But what we want to get to is that, for example, you will have your own router that does that on your behalf.
Yeah.
So your smart TV, fridge, whatever, will just all connect to a regular Wi-Fi network like you do now. And the device on your behalf will pay your neighbor's device.
Okay.
And you don't have to worry about it too much.
The main idea is that Tollgate will give you the possibility, of course, to connect and consume internet content through Tollgate gateways
Pay as you go.
and pay as you go. But also, I suppose the other side is the interesting part, no? That you can become
Yes.
the
yes.
seller of bandwidth.
Exactly.
So I suppose then my neighbor has maybe a Starlink,
Yeah.
and then he is getting some income maybe to pay the bill of Starlink and sharing. So properly
Yeah.
sharing the bandwidth.
Yeah,
that-
by a ratio of what people are using. If I am in a faraway town, we don't have many options. I might provide a Starlink, put a Tollgate behind it, and anyone in my neighborhood, like they don't have to come to me. The Tollgate is there. You just connect to it and extend the network because everyone can resell that internet, right? So we have this person that owns the Starlink, who will get most of the money because everyone's connecting through him. Anyone below can purchase, has their internet, is happy, and it can resell it at the same time.
Now I'm thinking you mentioned eCash, but there is many possibilities. I'm thinking when I go to many airports and I need Wi-Fi, this is normally paid Wi-Fi in many of them. So
Yeah.
and the payment systems are normally you have to buy $10 credit, and I say no, I'm not going to use it. I don't need
The
that.
whole sign-up forms.
Yeah.
Yeah.
So I suppose that the Tollgate could be an easy way for these kind of services that already exist
Yeah.
to resell
Yeah. Yeah. I
in
think so.
a convenient way. Even Lightning also that could keep on asking for more and
Yeah, so the ideal setup from a consumer device, phone, tablet, laptop, would be something in the background that is doing this on your behalf, right? You connect it to your Lightning node. It puts some eCash on your device because you need to be able to pay offline.
Yes.
eCash can be stored offline.
yes.
And it will do it in the background. It will look for toll gates around. It's like, okay, we found one. What's the price? Does it match my budget? Good, awesome, connecting, and you have access. So the perfect scenario would be you open your laptop, it connects, you're ready to go. You don't have to search for networks, select all that bullshit.
That's amazing because it's just like it changes completely your way of thinking because it opens something, a business that always was very custom made. Like this airport
Yeah.
has this system, this
Yeah.
other cafeteria, coffee place has this other system.
Yeah.
And this could be like in the Bitcoin economy, an open protocol or an
Yeah.
open way of doing it. You just download and
Yeah.
install and start earning from your bandwidth.
Yes, and all Tollgate does here, the Tollgate protocol does here, is like define a common way in which we talk about the pricing and the payments, right? It's like we need to
Okay.
agree on like how do I get the money to you, and that's all we need.
And how do you charge? Do you charge per bandwidth consume? What's the idea?
Yeah, so in the current stage, we work on just time, but we want to get bandwidth in there. It shouldn't be too difficult, but time constraints, it's something we want to add soon. So time and bandwidth are the main ones. You could also find other metrics, right? Maybe latency, but we're not.
Yeah.
It's too niche, I think. So you would define like which one of those metrics you're charging by, and then just say like what is the price per minute or price per gigabyte. Like the operator of the tollgate, which is his own ISP, independent operator, will say like this is my price. Actually, yesterday we were at the basement bar here in Riga,
Yeah.
and the bartender was very enthusiastic to start earning sats for their internet, and she was like, okay, I'll pay like €5, about $6, for a half an hour of internet, and we paid it.
Wow.
So we have our first market price for internet because
Yeah.
we were just testing before now, but now we've actually someone that set the price, and now the market has started, and anyone can compete, undercut, extend. Yeah.
Amazing. I have two questions. I will say them to not forget. First of all, is about if you have some earning model like that you can earn from such a decentralized system, if you will get a percentage of it. And also then after I will ask you about the risks of running a toll gate.
Yeah.
But first of all, do you have an idea to earn like a percentage of all those sats?
Yeah, so the software we developed, there is the option to add a developer split. So when the operator earns money, the router keeps a little balance. So say up to 100 sats, and everything above that will be paid out to the owner. And then it fills up again. And we repeat that. The owner can configure any set of Lightning addresses to pay out to. So say I want to say like send 10% to 10% to this cause, 90% or like 85% to myself, and another 5% send it somewhere else. And we obviously hope that the people that run this want to set aside a certain percentage to send to the developers of the software that they're running. But it's not mandatory.
Yeah. And then the second question, like, what are the is there any risk? Because when I think about a cafeteria, a coffee place, yeah, I don't see any risk because I know that they are offering free Wi-Fi as a claim to make you go in and have a coffee and work a bit. So yeah, anybody can access whatever they want with that Wi-Fi. But when I think from my neighbor point of view,
Yeah.
if I access that toll gate and then I start doing nasty things, it's his IP which is exposed.
Yeah. It's that's where you get into the legislation within between different countries. I don't know which country has exactly which legislation with responsibility of what happens on your address, which is kind of the reason we don't want to optimize for that, because we just can't. Like it's 180 different countries with their own rules.
Yeah.
So we would recommend people read up on their own, where you're going to run this, see what locally the rules and regulations in your area are, and see how you can comply with that, and what maybe your ISP is terms of service has, what their terms of service are.
Yeah, but I believe that these kind of places like coffee restaurants, which it's kind of accepted that they became a gateway to the internet for customers. I don't even know if legally that's okay, but we're doing it.
Yeah.
I believe that Tollgate can give them the possibility, not now to start charging to everyone, but maybe to say, no, you can connect to the internet, but if you're going to be consuming more than 1 gigabyte, I'm going to charge you. For WhatsApps, emails, no worries. It's okay.
Yeah. Anyone can set their own rules, really.
And what is the time frame? When do you see a proper market ready of Tollgate?
It's hard to predict, obviously, but we have the base features right now that we want to. Recently, we added the router-to-router payments, to divide the devices paying each other autonomously. We're still testing a lot of bugs, and I'm very happy with any developer that's enthusiastic to try this, give us feedback. And we just want to get as many people now working on this and building it for different devices, different niches, use cases. But I think it's going to be, at least half a year out before there's a solid, one solution you can just deploy and forget about.
Okay. How is Noster integrated?
We use it lightly. We try to prevent persistent identity. Right?
Okay.
We're cycling on our phones. We're cycling our MAC addresses, so we don't get identified by a router every time. So whenever we use it currently in the spec to make the payments, and we're debating whether we should keep that or not, or make it Noster, keep it Noster based. It doesn't strictly have to, but one area where Noster is very important is advertising. Advertising that you have a tollgate, that it's around here, and reputation. So a tollgate can have a pub key, and we can assign reputation to that pub key, right? If you are a provider, you will probably want to build your reputation so that people come to you instead of the next door neighbor.
Well, what is the point in advertising it? Because I understood it in the coffee idea, in the neighbor idea, that you will just see, you will open your Wi-Fi that you have next to you, and you will see, oh, this is a tollgate, oh, great. But what is the point in advertising it on Noster?
I think early on, it would be nice to have like you could chart it out basically. For example, this is a use case that's open to explore.
No, for me, it makes sense that then if I see in my vicinity a Tollgate Wi-Fi
Yeah.
and I see an identifier,
Yeah.
then I can check on Noster
Yes.
reputation.
Yeah.
That
But it's going to take a while before you have that coverage where
Yeah.
you can kind of assume there's going to be toll gates around
yes,
to connect
exactly,
to.
exactly. But no, but really, even you don't even need to know what Tollgate is. If at
Yeah.
some point you just see the coffee that you are in, you see
Yeah.
that it has a Wi-Fi, you connect and you have a pop-up and
Yeah.
it tells you, look, this is how we work. And
Yeah.
if you want to consume more, you have to
Yeah.
pay in Lightning and Bitcoin. And okay,
Yeah.
I'm in, no?
Yeah, maybe the word advertising is a little misleading here. I don't mean advertising as in like putting up a billboard. I just mean
Yeah.
the device announcing itself like
I exist.
I exist. Like
Yeah.
right here on your phone, you see the list of Wi-Fi networks. Like
Yeah.
that's kind of what we're talking about.
And yeah, and as a last point, interesting because now I hope that Kale will come and some other Cashew developers. The importance of being able to pay with eCash is this offline part of it, no? So that the consumer that doesn't have internet, that's why wants to connect,
Yeah.
needs to pay and with something that can be used offline.
Yes.
And here is where Cashew helps, no?
Yeah, that's where Cashew shines. This wouldn't be possible really with Lightning, because with Lightning we would have to, allow someone on their phone to bypass, and then you get into all kinds of tricks that can be bypassed as well. So the offline is really a big thing. Then there's also the frequency of payment and the fees, because if I would make this payment on Lightning all the time, like we said, we prefer to make payments as small and granular as possible, say every 10 seconds, for example. If you do that on Lightning, it's going to be, it might be fast enough, but you're really stretching it. And also the fees would just add up too much,
Okay.
and you want to make really small payments. And we're already hitting the issue if we want to pay every 10 seconds. With current normal Mint implementation, the minimum payment is 1 sat, which would add up to about 3,000 euros a year. And if you calculate that in real money, like gold, it's like 34, 36 grams of gold every year. It's probably not what the internet is, your internet
Yeah.
access is worth. So we're already looking for using millisats
With
denominations.
eCash.
Yeah. Because sats are just too big. Otherwise, you have to increase the window you have to purchase, and then you get into all kinds of credit issue. Because if I purchase an hour with you, and I walk away, come back, and you don't provide me with internet anymore, I'm going to complain with you, right? It's like, why are you not giving me my service? Whereas instead, if I would give you a 10-second payment, and I would walk away and come back, of course, like it's going to be run out. Like I don't care. Our customer operator relationship ended just there by me walking away.
That's really interesting, and also, with Cashew is great because you can see how it keeps on evolving and it keeps on. When you see a need, Cashew is such a flexible thing and so alive that it can still change and it can still provide you the solution you need.
Yes, absolutely.
This is great. Arian, thank you for joining.
Thanks so much.
It was really interesting. Of course, I wanted to talk with you and to get to know a little bit more about Tollgate, but after speaking about it, I'm really excited. So I look forward to see some of these gateways popping up.
Me
Near
too.
me, of course, near me.
Yes.
So thank you for joining.
Thank you for having me.
And now I'm gonna do as I did before. I'm gonna go grab someone else. They are finishing eating, so I think it's gonna be. Did you manage to eat something?
A little bit.
Okay. So let's
I
go.
need a second round.
Yeah. Let's go for it.
All right.
I'll be back.
I was supposed to be on, but I don't know if you're behind or what. My name's Derek.
Eric,
He's a Cashew designer, privacy by design.
please come.
I can wait if you want to eat food.
No. I already had a lot of breakfast because I know that now it's this time. Right. We're finished. And so you're Whenever you're ready. Really need to put it down. And I think it was me and another guy. Do you want me to go get him? Or
Who else was?
Josh Rush?
Yeah. I mean, we can be the three of us. What?
I don't know, whatever you want.
Oh, we can start, and then maybe he can join, because these invites.
Yeah.
Okay.
Is it live?
Yes, we're
Oh, we're
live.
live.
You were live.
No way.
Yes, we are.
Oh, man. I didn't know how many people are watching. How many people are watching?
Now we are here. We're both in. This is my channel, and also there is on Twitter. I don't know, and in Bitcoin plus plus. So in total, I don't know. In my channel now
cool.
we're 24. Now it went down to 19 because I abandoned the stream. But yeah, Eric.
Hey, thanks for having me.
No, I even asked before Lisa, like, who is Eric? We met yesterday. We saw each other
yes.
during dinner, but I didn't know you were Eric because I saw your talk, and I say, okay, I want to know more because I'm not seeing any talk
Okay.
here.
Of course, working.
Yeah, I mean, working, enjoying conversations. So, yeah, I wanted to know more. What was exactly the title of the talk?
Yeah, it was called The State of Cashew Design, Progress, Risk, and What's Ahead. And it was largely about the latest and greatest in Cashew, which is an eCash protocol for those that aren't out there. It's the latest designs, things that we're doing well, things that we could be doing better. And I also talked a little bit about vibe coding and my new methods for actually pushing live code. But it was predominantly based on the design of Cashew and how we're visually and actually implementing features onto the different wallets that exist now.
So more on the UI or everything?
A little bit more on the product side. So definitely the UI was very important, but it was also about the psychology behind like why some of these decisions that we made work, why some of them are kind of working, and what we could be doing better. So
Yeah.
a lot of that was the visual interface, yeah, for sure.
Okay. Cashew, I think that today I'm going to be talking a lot about Cashew. But yeah, for some people, Cashew is that thing that they are not really interested because that's custodial, that I'm not really into that. But for whoever uses Nostr and is and interested in Bitcoin stuff, Cashew is all over the place.
Yeah,
And
it's gotten very popular.
yeah, and I wanted to ask you, like, how do you see Cashew right now, and with all this analysis that you did, which are the biggest limitations you see now?
Well, the biggest limitations I think are some of the challenges that users face when they first start using Cashew. So I guess the big issue is mint discovery, I would say. There's two I would say major issues, like simple issues for like the ones that everyday end users care about when you put a Cashew wallet in front of them, or they start making a decision as to whether or not they want to use Cashew. One is mint discoverability, and the other one is like risk mitigation and protections from rug pulls, because you're giving up your custody of your Bitcoin to a custodian. So how do I prevent me from getting rug pulled is the second one, and the first one is how do I even know which custodian to pick, which mint? How do I know which one is reputable and which one is trustworthy? So those are the two biggest hurdles I think that we have to face. And I say we, I mean product designers, people that are not necessarily engineers, but thinking about how to solve the problem for like the regular person that uses the wallet. Those are the two big things that we can probably make the most impact on by improving.
Is there, are there ways to avoid being rug pulled, or to do some due diligence in advance, something like that?
There's ways to mitigate it. One of the hackathon projects actually is looking into like a pretty significant risk mitigation problem, the Spillman eCash project, but I'm not going to get into that because they just hacked it together in 2 hours. But right now, as to what exists to prevent someone from being rugged, so outright prevention, no. You're trusting a custodian. At the end of the day, if the custodian is going to run away with your funds, you're done. But there are methods that exist and there are tools that exist right now that let the user make a more informed decision as to whether or not this mint is trustworthy. Particularly that tool is called bitcoinmints.com. and it's built on Nostr, and it allows people to rate the mints, simple like rating system like you would see on Yelp or TripAdvisor. And there's another tool called the Cashew Auditor, or the Round Robin Auditor. And this is a little bit of a more advanced tool where what this tool does is it allows you, it has a list of all the different mints that exist that have been sent to the auditor, and then this is perpetually doing a melt transaction where it's taking Lightning invoices and paying them from mint to mint, and then it's giving it a rating as to did it succeed, did it fail, how fast was it, for how long have we been able to successfully get in and out of the eCash mint without any failures, and then it assigns you a very simple, human readable metric. So it's either green, 96%, 50%, 40%.
Okay.
It assigns it a speed, so you know how quick these things are. And then you see a
Kind of a
time range.
health metric,
Yeah,
no, in a way?
it's like a very simple health metric. And right now in a lot of wallets, it's not as, I think, optimally designed as it could be, but this round robin Cashew auditor that you can use to see the health of a mint in real time before you choose to add it or at the time that you're doing mint selection is something I think could help with the risk mitigation and the rug protection.
Great. And then that's the risk, and yeah, I believe that this is, first of all, that what people that haven't used Cashew but wants to try this, I believe, is the biggest fear.
Oh yeah.
First of all, not understanding how it works, and second of all is like, okay, will my 1,000 sats or 10,000 sats be gone? And but aside of that, I can see Cashew keeps on growing, and it's funny because users use it, but also developers are really interested in,
Yeah, they are.
in creating and stuff around eCash. Why do you think is that?
I think
Being such an anti-Bitcoin ethos for a lot of people. you
right,
know?
it's literally trust.
Yes.
Yeah, it's literally you're giving up your Bitcoin and trusting someone else with it, which is on the surface almost like heresy to Bitcoin, right? It's like being a Protestant. It's just like the
So what happened with you all? You went crazy that you are dedicating time
Exactly.
to eCash. What happened there?
Well, let me, I guess, address your first question, which is like the developer like excitement and the level of development that's happening on Cashew. Why? And then there's the user point of view. Why do people actually enjoy using Cashew in the wild? Because I think the two things are related. So let me talk about the user first, the end user. So what's special or what's interesting if you're an end user and you want to use Cashew? The user experience of Cashew is radically different than the user experience of Lightning or on-chain Bitcoin. And I'll explain why. So when you do a Lightning transaction or an on transaction, if I want to send Bitcoin to someone, I want to engage in this very human peer-to-peer exchange. If I have Bitcoin in on-chain or Lightning, I can't just give it to you. I need you to tell me where it's going. I need you to give me a Lightning invoice, an LN URL, or an on-chain address, right? Now you could argue, okay, well I could do an open dime on-chain and, or I could write down a private key and just give you a private key on paper, but that's all on-chain. And what if you want a specific amount? Like, hey, I just need 25,000 sats or whatever the case would be right now. You might not have an open dime with that amount, or you might not, want to write down a private key. So you actually can't really do that with Bitcoin in the way that you can with eCash. It unlocks like this push UX or this throw UX where you can just take eCash, put it in a string of text, and then you can translate that string of text into a QR code, into an NFC, and then you can just throw it. So I can just go up to that person over there and I can just hand them eCash, right? I can throw this money. And that's very similar.
Basically, it's like the meme.
Yeah, it's like the Salt Bay, but it's also more parallel to how physical cash works, where you just pull out a bill and you just hand it to someone, and you're pushing it to them. And that person that's receiving the bill, they didn't need to give you an address, they didn't need to tell you where their cash register is, right? You just hand it to them. So it mimics that kind of peer-to-peer kind of human user experience that we have with cash. And on the developer point, why is there so much developer interest in Cashew? I think that a large part of that is because the code base is so lean, it's so small. The developers tell me that I have an application, right? It doesn't have to be a Bitcoin application. It could be something that's like tangentially related to Bitcoin. Like you could have like a chat application or whatever the case may be, and you want to have Bitcoin functionality. You want the users to be able to interact with money with Bitcoin, but you don't actually want to deal with a complex code base of putting like lightning nodes on your code or any of this stuff. Well, you could just simply implement the eCash code base into your app, and then your app supports Bitcoin.
Okay.
And of course, there's the trade-offs. It's custodial Bitcoin. The user has to pick a mint. All these things still exist, but you can take a very lean code base of Cashew, just throw it in your app, and now your app supports Bitcoin. And developers love that because then it's like, okay, I don't have to be, like maintaining all this stuff. I just have a mint implementation in my code base, and the people can now pick their own mints, make their own risk profile, and they can use Bitcoin. They can receive, they can send it, etc.
This is great. What would you say to this? For example, happened to me. Like I get some value for value, and some people send me eCash through a DM, for example, on Noster. Hey, thank you for your work. Here you are. And then I start. Okay, I get this eCash, then I get another eCash, and they are all from different mints. Then the first time that you see this, you are like, oh, what's happening here?
Yeah.
Like, what do I do? Should I unify this? Should I? Well, when you find yourself in this situation, what's your way of thinking?
So I think that's very common and a very real problem. And I think
Sorry to interrupt you again,
Yeah, go
because
ahead.
this is the same feeling a little bit I had many years ago when I started using Bitcoin, and then my hardware wallet gave me another Bitcoin address, not the same as I used the last time, and then I thought, oh, the hardware wallet is rug pulling me.
Yeah, exactly. Why is it giving me a different
happening?
address? So I have that one, yeah.
And then this is the same feeling that when you see you have sats in different mints, it's like, that's no bueno. I need
Yeah.
to somehow unify this. It makes sense or not?
It makes absolute sense, especially because the thing about eCash is that anyone can spin up a mint, and that's good for censorship resistance and decentralization. But it also creates this kind of any rando on the internet can now just have an eCash mint, and you want me to trust some rando's eCash that I don't even know is good? I'm not so sure about that. So I think this is like an upstream problem. So if you try to think about the problem at the root, is that the user wants to be able to have the convenience and the user experience of eCash, but they don't want to have to sacrifice the issue that comes with trust and security of just allowing other people to just send you whatever eCash from whatever mints. So I think there's kind of two things in play here. One of the things that eCash wallets do support is auto swapping. So you can set a mint as your default. Like let's say you only want to trust the Bitcoin plus mint, or if you're at PubKey in New York City and you want to use the PubKey mint because the guy who owns the bar and whatever the case may be, you can set your wallet to have that be the default mint, and every time you accept eCash from someone else, it's going to melt it and then put it into your mint. But at that point, you might say, well, why not just use Lightning? Because it's doing a Lightning transaction into a melt of your own mint. I mean, that's, like a fair criticism, and that's part of the trust model. But, that is one solution, is the auto melt. Another thing that we have is something called multi-nut payments. Have you heard of multi-nut payments? Okay. So what it allows you to do is get rid of the inconvenience that exists right now when you try to pay a Lightning invoice for an amount that's greater than what you might have on a single mint, but you might have spread across multiple mints. Now you can just execute the payment and it'll work. It'll just take 50% from this mint, 50% from the other mint, fuse them, and just execute the payment in one go. So you don't have to constantly do this kind of juggling and balancing act.
When you say fuse them, what happens behind? Like, does it first goes to one and then jumps, or how is it technically happening?
It has to do with the HTLC and the routing paths. I think. Let me see if I can remember this, because Lightning allows through the HTLCs in Lightning allows multiple paths for payments. I'm probably conflating the explanation, but
The multipath payments and so on.
Yeah. So what multi-nut payments are doing that is I think they're using LND to like execute these multi-path payments through like the Lightning like HTLC system. I'm sure
Okay.
like a more technical developer can kind of look into it, but this is like my high level understanding.
Okay.
I'm more on like the product side.
Yeah.
So like the engineering of it is not as relevant as like how do we present this to the user. So I'm more focused on kind of the product side, but I think that's the explanation for what I could remember. It's been a while since I looked into it.
What I really like of this conversation we had here is that, yeah, anybody can spin a mint.
Yeah.
So if I'm really interested in sending you some value, for example, 1,000 sats, but you're not online or you don't have a Lightning address or something like that, I can just, without asking, as you said, just say no, fuck it. I have my own mint. I'm gonna send you eCash from my mint. And this mint is not like a community mint or something like that. No, it's my mint.
Yeah.
And it's for these kind of things that whenever I want to pay someone, I can do that. No, and it's like, here you are.
Exactly.
Pick it whenever you can.
Exactly.
And if you don't pick it, sats are still in me. So
Yeah.
I didn't send those sats to a Bitcoin address that you will never check or you will never access. No, that's also a cool part of this custodial side of things, that I keep custody only the moment that you claim them.
Exactly. And so it has that safety of the trust, of the social layer of human trust, where like, this is from my cousin, and if they're not tech savvy or they mess up, I still have the ability to retrieve the funds. I think that's a fun use case. Something that I didn't think about was when we were at BTC Prague, we had these paper eCash notes that we were handing out with these cool designs and these QR codes that anyone could scan and claim the money. And I gave it to a gentleman, and he was like, oh, you know what? My kids would actually love this because I run a mint and I pay my kids' chores in eCash. Because, if my kid loses the wallet or breaks his phone, I can just, retrieve the money. And he's like, I'm not going to rug my kids, but I want to be able to just pay them in eCash and know that I have the backup. So he was just saying like, yeah, I could actually just print these out and just give them to my kids. They would love to receive this. And that's kind of an interesting kind of model, like, because you have that social trust layer, which is very scalable. That's one of the things that I think in Bitcoin we're very, don't trust for good reason. But trust and human connections are very scalable, like in terms of a community. Like these things kind of work.
Yeah, and you don't need to trust your life savings.
You don't need to trust your life savings.
We're talking here about what worst scenario, maybe $100 or something like that, and you can always claim on to Lightning, no?
At any time, yeah.
Anytime.
Yeah, if the mint is honest and operable, you can withdraw to Lightning.
And that's the thing, no? I'm paying whenever I want to you, claim it, and of course you can claim just the eCash, or you can just convert those sats to Lightning, and then bye-bye, you're out of my system.
Exactly.
You're not trusting me anymore. So it's up to you, the receiver, to make custody as it should. If you don't claim it, it's because it's giving you a service in a way, this eCash token that you still have from me, because maybe you will pay me back something or send me back something. Okay, up to you. But if not, just claim it.
Exactly.
This is great. Last question. What is nowadays, your go-to wallet?
eCash or
Yeah,
otherwise? It's Macadamia on iOS. So macadamia.cash.
Okay.
It's developed by a developer named Dario, and it's built with Swift. For those of you that don't know, Swift is like Apple's native programming language for their applications. So what Swift allows, if you program an Apple device in Swift, it allows you to have these really beautiful kind of micro animations that really make the application feel polished and like magic. Like the way that like the bubble like kind of contracts and then does a little bounce and locks. And it's these small little elements of magic that when you use an app and you're like, oh, that's nice, it makes people smile, that's usually like a micro animation or some like beautiful thing. And Swift on Apple makes it very easy to kind of have those effects. So if you're on iOS, my go-to wallet these days is Macadamia. I think it's probably one of the most beautifully designed eCash wallets. Android, definitely Minibits. Minibits.cash is a powerhouse wallet, very reliable, very beautiful, simple to use. It also gives you an eCash address, which is nice. It's like a Lightning address that you can just get automatically and start receiving eCash, which is good.
Beautiful. Eric, it was a very interesting conversation, and yeah, I believe Kale should join after. I don't know what I will ask to him after squeezing you so much with Cashew.
Oh,
but-
he can get far more technical than I can. So
No.
yeah,
Well, but
definitely
it-
go there.
but it was great, and yeah, thank you for joining in the to the live desk.
Thanks for having me.
Let's go. Maybe we can eat something still.
Let's do it.
Okay, I saw that Super Attachment was here before.
I think I can take it, yeah?
Yeah, this yeah. But no, outside
Very well, very well. I just had a delicious lunch. Nap time. I'm a volunteer. Where's the beer? I don't know. We don't have alcohol. Which I thought.
And we're back with our next guest. He's joining. I'm reading some comments. Really nice. Forte from Cuba saying that eCash is very important for the Cuban. With eCash, we can make offline transactions. This is great. Yeah, I saw that Kale was talking now. You were listening to him, no?
Yeah.
And I hope that after he can come. Elias,
Hi.
thank you for joining.
Thank you.
Yesterday, your talk, I was telling you before, was one of the ones that I was sad to miss because it felt really interesting. For the audience, what was the topic, the title, sorry, of your talk?
The title was State of Lightning Privacy.
And yesterday, I was speaking with Claudia, and she was not really optimistic about the state of privacy in Lightning. What can you tell me about that? What's the state of Lightning privacy?
So I think, for one, we have to see that the Lightning in general is a vast improvement over on-chain privacy as a first step from always was. Then more recently, we made some more improvements, even gained additional properties, naming receiver privacy with Bolt 12, because previously, before Bolt 12, a sender always had to exactly know how to reach a receiver, and now we can actually...
Well, I'm gonna, sorry to interrupt, but I'm gonna tell Super, join also, we can be 3 of us, because otherwise we will not make it. We're talking about Lightning privacy.
Great. That's a topic that's of interest to me.
Great.
Am I?
Okay, no, yeah, we can.
Oh, there's just a lag.
Yeah, this is live. So you were saying, sorry? With
yeah,
Bolt
more
12?
recently with Bolt 12, we definitely made some improvements, but of course there are still some areas like
potential on-chain, on-path attacks, and also as network-level attacks on privacy, that we should at least be cautious about and try to improve the protocol to hopefully mitigate such an attack if they were actually being conducted.
I have an objection to Bolt 12 privacy.
Okay.
So one of the things that I focus on is removing the public key from invoices. So when you create a Bolt 11 invoice, it has your public key in there. That public key is tied to your node. If someone finds your node, they can look up your history of transactions and map them to ones that they sent you. It'd be great, or it is great, that with Bolt 11 you can put a dummy public key in there, and some services support this. Like if you use blinded routes, use a dummy public key. Bolt 12 is supposed to use a dummy public key. It's in the spec to use a dummy public key, but it has an extra public key in there. It's like one that's just used for signing messages related to that Bolt 12 invoice. And the way that the implementations do it, that one's not a dummy public key. All the implementations I'm aware of put a public key in there that's derived from your seed. And so anyone who sends you money, they can, if they later get your node, they can still look up your seed phrase, get your private key out of there, and say we can prove that we sent him money because the public key is the same as the one that was in his Bolt 12 offer. And so I object to this. I think the way Bolt 11 does it is actually better than the way Bolt 12 does it.
But did you not just say that you can still do it in Bolt 12? It's only that the implementations are not doing it. So in Bolt 12 you cannot use a dummy pub key then?
Yeah, my complaint is about implementation level. Yeah,
Okay.
The spec does allow you to put a dummy public key in there. So putting one in there in the actual implementations is important, and not deriving it from your actual seed phrase.
Oh.
To be honest, I'm not fully sure what the current state in LDK is, but I know that we definitely considered or actually planning to move to using SCIDs in the blinded path, because originally you also would always need to use full public keys in the blinded path, and by now you could also put SCIDs in the blinded path, which could of course be SCID aliases, so no permanent identifiers there. But yeah.
I'm talking about
The public key I'm talking about is the one with which you sign the invoice. So you have the Bolt 12 offer, then they request an invoice, and you're supposed to sign that invoice. You give the public key in the offer that says, if you get an invoice signed by someone other than this public key, it's not me. We've been man in the middle. Don't pay the thing. But that public key is, as far as I'm aware, in all of the implementations of Bolt 12 right now, it comes from your seed phrase. And that's bad, because if someone gets your private keys later, if someone confiscates your device or something, then they can identify any invoices you've received or any payments you've received and map them to the invoices or to the Bolt 12 offer that came in for that. So you can improve your privacy by not having that public key be generated from your seed phrase, and then they can't do that. Like, there's no link between the private keys they get on your device and the Bolt 12 that they paid previously. So that is the thing. Now you know.
Okay. Going back to the state of privacy, maybe I'll ask you like this, and maybe we can then continue with Super Testnet and his ideas, and Hedgehog maybe. What would be, Elias, for you, the best part of Lightning privacy now in August 2025, and the worst part, the one that we should be taking care and working on?
I think the best part is clearly that you are somewhat decoupled from your on-chain footprint, so you can send payments without actually leaving an on-chain trace and broadcasting it to the whole world. That is a vast improvement. The worst part, probably the most pressing issues is indeed network level attacks, I would say, maybe. Meaning that an autonomous system that sees a lot of network traffic of Lightning nodes, for example, AWS, Amazon, there's one specific AS that has I forget the number, something like 30 or about 30% of, where basically one end at least of each Lightning channel. If you control this AS, you have insight and see a lot of Lightning network messages, even from the outside, without being able to look into them. and they could leak a lot of information. That might be the worst of Lightning privacy currently. It's hopefully a theoretical attack that nobody actually currently exploits, but we don't know that.
As far as we know.
Yeah.
Super. You have had some nice conversation on Twitter, I believe, with
Some nice conversation. Oh, that's very generous.
so with asking, like, I believe it was Monero users, like if they could identify the good part that Elias just mentioned, that it's hard to track Lightning payment. Would you agree with what he said, or do you see some better side of using Lightning in the privacy aspect of it, or another bad part of it?
Lightning has bad receiver privacy, and in many ways it has bad sender privacy too. When I talk to Monero people, what I'm often doing is a relative comparison. I'm saying if you compare it with Monero, Monero's has even worse receiver privacy. Monero has even worse sender privacy. And in some ways it even has worse amount privacy, although that one's the one where Monero does the best, is with amount privacy. But even there, in some ways, they're worse than Lightning. So yeah, that's not to say that, like, people get this impression. They're like, well, Monero's untraceable. Super is saying that Lightning's better than that, therefore Lightning must be untraceable. It's not true. Neither one's untraceable. Like, they're both traceable. But I think it's harder to trace Lightning. Like he was saying, you have to do network analysis to do this. You have to find the Amazon nodes and subpoena them for information, or do data sharing partnerships with them. Whereas on Monero, your starting point is a public blockchain. Every transaction is published to there. You can go immediately to the blockchain and start analyzing the transactions and eliminating decoys and stuff. It's harder on Lightning because there's no public, the transactions aren't published, and that makes the starting point for chain analysts harder.
What about the receiver privacy? Because this is one of the when you get to understand it, this is, as a user, one of the things that you start to think, okay, how do I do it? Okay, I will start using LN proxy first, or try to wrap this information of my node and try to protect. Then offers come, blinded paths come. Can we get better?
Yeah, we are getting better. One of the things that is a struggle in Lightning privacy, specifically with the receiver, is that most software implementations put a public key in your invoice that gets reused. So every time you create an invoice, you reuse the same public key in each one. This is bad for receiver privacy. Services like LN proxy and blinded routes make it so that you don't reuse a public key. You put a different one in your invoices, sometimes even one that doesn't belong to you. That's really good. Bolt 12 kind of does this, but that was what my complaint was earlier. It does that for part of it, but then it puts a different public key in there, which is tied to your node, and it gets reused for every payment. So I don't like that's a negative for me about the way Bolt 12 does it. And I'm trying to raise the alarm now while it's still not very widely used, so it can be fixed, and then like do better.
Okay, but nevertheless, I mean, as I believe you said first, that with Lightning, we're in a better place in privacy. I think it was super, but that we're in a better place for privacy compared to, for example, how regular people use on-chain, which they don't think about UTXO management, and they just mix everything, and everything is unclear on the blockchain and accessible for everyone on a mempool. So we're in a better place. Of course, many people use custodial services. So, to be said, Lightning is better in privacy if you manage everything. Maybe you don't agree with this, but if you're using, let's say, Wallet of Satoshi, you don't benefit a lot from, or?
That depends.
Okay.
Depends who you're protecting from. The issue with on-chain privacy, as Super just highlighted, is everybody can see everything. So if your on-chain privacy aspect is bad, everybody in the whole world can actually exploit it and learn a lot about your node. If you use Lightning, even if it's custodial, then yes, you're giving Wallet of Satoshi in your example all the information, so you're naked before them, but everybody else still doesn't learn anything.
Well, Wallet of Satoshi and many of the custodial wallets often have data sharing agreements, and you can find this out by reading their privacy policy, where they say, well, I don't know if I haven't read their privacy policy, but many of them say, if you use our services, we get your data. We share this with our partners and data
Right.
analysts.
That
So-
comes down to who is your attack model, basically. So, of course, if you're considering, for example, government, then yes, if you are using a custodial service that has a data sharing agreement, then they might share with government agencies the same data. So you, of course. But if you're, again, if you have bad on-chain privacy, the whole world, even your competitor, even other governments that aren't your own or the US government, are learning everything, basically. So I would say even if you're self-custodial, you at least can pick your poison, basically, who you share data with, even if it's not self-custodial.
I believe that maybe with something like Wallet of Satoshi, it's a little bit like the same relationship you have nowadays with a bank. No? To the bank, you're fully naked. But when somebody's paying to your account number, doesn't know anything about your balance and so on. So you kind of have some privacy to the outside world. Of course, authorities, if they want to know, they can ask the bank and then get that information. But it could be something like that. The good part is that we can be our own bank and spin everything up and do it for ourselves. But just to finish this conversation, super, you are a really productive person. You keep on producing stuff. Sometimes it's impossible to keep up. But there was this...
Thank you.
Yeah, the Hedgehog payment channel system. I don't even know how to define it. But could you first of all explain what is it?
Yeah, Hedgehog is an alternative way to do payment channels that is very similar to the Lightning Network, but is designed to make, it's designed from the ground up to support asynchronous payments, which is, to me, the Lightning's biggest failure is that if I want to send you money, you have to be online in order to receive it. That, to me, is the biggest problem or UX problem with Lightning payments. So I designed Hedgehog to be an alternative construction that fixes this, and you can send people money when they're offline, and that's what it's for.
And how do you do this magic?
Well, it depends. If you have a direct channel with someone, it's a lot easier because both in Lightning and in Hedgehog, the payments are when you pay someone, you're creating a transaction and signing it. And if you have a channel with them, your counterparty is the only other signature you need, so you can just send them the signed transaction and then go offline, and you don't need to be online. Whenever they get online, they can complete it. They can supply the missing signature, and now the transaction's valid. So that's how we do it if you have a channel with them. If you don't have a channel with them, well, that's what I'm presenting today. I have a way of having there be a server that you create an HTLC and send it to that server. And in Hedgehog, I use relative time locks, so this doesn't cause force closures like my previous solution to this did, which is called ZapLocker. In the new solution, you send a HTLC to this server that has a relative time lock on it, and the server wants the secret, the pre-image, that allows them to spend that money. That's what you give to the to whoever you're paying. You give that secret to them, and then they basically sell it to the server. They say, I have a pre-image that you want because you'll get 10,000 sats for getting this pre-image, so I will give it to you for a 10,000 sat Lightning payment. And then the server does that because he wants the money and gets the pre-image and then settles the HTLC. But the nice thing about that solution is, once again, the sender doesn't need to be online when the recipient comes to collect. If you have a direct channel with someone, you don't need to use an HTLC. You could just sign a transaction and be done. If you don't have a direct channel with someone, then you use a third-party server. You send them an HTLC. They can't collect it until they buy the pre-image from the person who you really want to pay.
Okay, but then you introduce this server in the middle, so a bit more infrastructure that needs to be working in order to do that.
Yeah, it is. It's similar to actually, I got the idea from Matt Corallo's specification for how to do asynchronous Lightning payments. But his specification has two LSPs. It has the sender having an LSP and the recipient having one. And what I think is an improvement is that I only require one. Just the sender needs an LSP where someone who supports this protocol, that he can lock that HTLC up with, and then the recipient can come on later to collect.
Could this be connected with Lightning and work together
Yeah.
with Lightning, or it
Yeah, I
should be-
use the same length pre-images and hashes. I use the same hash function as Lightning. So I have, in fact, routed these in some of my tests. I've routed these over the real Lightning network, and real Lightning nodes can't tell the difference. They're just like, sure, I will propagate this pre-image back. You know, they don't know it's a Hedgehog pre-image because it uses the same length and the same style.
So it could be a feature to be added to the Lightning network, let's say, in a way.
Yeah, you could. There are already some Lightning wallets that let you do this, but I need to. My software isn't ready for it. Isn't ready to do it. And also, in production, it won't be my software anyway. I always just make demos to prove how to do it, and then hope someone else will build a real thing. So, you know, I'll be presenting one of my demos today, showing how this new technology can work, this new way of doing asynchronous payments, with the hope that some of the wallet developers here will be like, I want that in my wallet, and then they'll make a for real version.
Having Cashew already with us, the difference, because with Cashew you can just push and it can be asynchronous, no?
Yes.
The difference would be that it is this
Custodial.
Is, exactly.
They have the server in their model has custody of the funds, so there's a third-party custodian. You put money on the mint, then you can give someone the eCash token, which is basically a promissory note. You're saying the mint will redeem this for the amount, but of course they might not. They might just go down and refuse to redeem anything for anyone. With my server, the sender locks up an HTLC in such a way that if that server goes down or refuses to forward the payment or whatever, it's just like Lightning, it goes back to the sender, and so you don't have a third-party custodian in here. The sender has the money until the recipient sweeps it, and that's the model that I prefer, because you eliminate the trust assumptions. Some of the trust assumptions.
Elias, any thoughts on that? Or any last commentary you want to add?
No.
Good?
Yeah.
Do you like Hedgehog?
I didn't have a closer look yet, so.
Okay. So
Interested
you
in
will
talk.
have to...
Come to my presentation later.
Good. Thank you guys for joining. It was a great conversation, a very fast one. And yeah, when you get technical, it's hard to follow you, but it was great. Thank you very much for joining. And yeah, see you around.
Great, thank you.
Thank you.
And now I'm gonna be looking, maybe Jeff finish and he will be joining. Oh, can you join? I didn't see you. I was looking. Are you ready? Like, you have your whole thingy to join? Okay.
Can you give me 2 minutes?
2 minutes? Yeah. I'll give you 2 minutes. Not 3. 2. Easy, easy. I will. We're live all the time. I'm gonna use this moment to go to the toilet, get a new coffee, and now, I don't know if you heard, but it's gonna be joining Kale, creator of Cashew. So yeah, it's gonna be a nice conversation. Yeah, be back in a minute or two. Okay. What I'm doing is I'm switching on also BitChat. We'll be talking about Cashew and of course BitChat, the app that Jack Dorsey created and that Kale ported to Android. So I believe he's the main developer of the Android app. So now I see in BitChat, maybe I don't know, yeah, it's far. But I see two people connected. Maybe we'll try it with Kalem.
I'm just going to put my coffee in here as if I could drink.
Are we live? We're live all the time. I'm showing them BitChat. I just open it. Hi from
Hello.
The live desk. Do you have it with you?
Yeah,
No?
I do.
Let's do a live testing of
BitChat?
BitChat, yeah.
I'm starting it up.
I was thinking yesterday that,
Yeah.
of course, I just send this message, hi from the live desk, before you switch it on. There is no way for you to access all messages, no?
Well,
you were
there's messages are being cached on devices, and then they are kind of forwarded to those who come online later. There's
Really?
some form of caching, yes. I'm not sure if it's like fully reliable yet, but because it needs like some tweaking on the parameters. But the concept is existent in the app. So you will cache some messages you cache messages. If there's anyone online around you, they will keep the messages, and then when you come online, they can just dump a few of the past messages to you.
Nice.
Mm-hmm.
I was thinking because, okay, maybe we can start with BitChat. It's I see.
Do you see my message? I just sent you.
Yes, I see. Okay, let's see how long it takes.
For what?
This for you. Oh, it was automatic. So we have direct connection.
Let's see if we have a direct connection. Yeah, we do. Like according to my phone, we have a direct connection.
And how do you see this?
The fact that so it only shows the direct connection on one side because the indicator. So you can see like you have a direct. No, you can see it too. So you have a direct connection to my phone. You see it with the signal bar.
Ah, okay.
And then you have a direct connection to the Max.
The Max, but not with Nifty, for example.
No direct connection with Nifty, and I also don't have a direct connection with Nifty, but you can probably reach Nifty, and it will just at least takes one hop at least to reach Nifty, and probably through the Max because I also don't have a direct connection with Nifty. So my guess is if Nifty would see my messages, it would hop through you and then to the Max and then to Nifty.
This is nice.
Yeah.
BitChat. Okay, so yeah, we started talking about BitChat. Maybe somebody doesn't know what is it, but basically is a messaging application that communicates through Bluetooth.
Bluetooth Mesh, yes. Bluetooth Mesh is the first transport that we've implemented. I think we can extend it, but for now it's a Bluetooth Mesh chat app with upcoming Nostr support as well. We can also talk about that.
Okay. Mesh in the way that, as we were saying now, we are both connected and I didn't have to ask you for anything because we are close to each other. So our Bluetooth, and we don't need to pair. Like normally people is used to use Bluetooth and then first of all you have to pair with your car and then connect and accept pairing codes. Here no.
Yes.
Here it's,
so this uses Bluetooth Low Energy, and that's the reason why you don't need to pair. So the normal Bluetooth protocol before BLE, it's also called BLE, Bluetooth Low Energy, it required you to confirm the connection on both sides, and then you establish the connection. For Bluetooth Low Energy, they got rid of that. So that's what powers most of the devices today, like your headphones or just Find My devices for iPhone that people know. And Bluetooth Low Energy basically just can scan the entire surrounding of you for devices. You see a list of devices that you want to connect to, and you can say, establish a connection, and then the other side can just accept the connection if they like, and then you have established a connection.
Okay, but if they like, it feels that when you have BitChat installed, it's automatic. It's like you're already accepting incoming connections.
Yes, that's the app itself decides whether you want to connect or not. So
Okay.
there's something called a UUID, a service UUID, in which Bluetooth devices announce themselves publicly. That's a random string. It looks just like a random string. And then what manufacturers do is they choose a random UUID, let's say for Apple AirTags. They have a special UUID. And then every iPhone knows this UUID that the Apple AirTags have. And when you say scan, then you see all the Apple like the Apple Find My tags, AirTags around you. And then you can kind of press connect. What happens is that the Bluetooth chip connects directly to the Bluetooth chip on the other side. And then in that process, then on the other side, the app that controls that connection needs to say okay.
Okay.
So it's not like the establishing the connection where you verify and say like couple, or it's there are different ways of bonding and something it's called, but where the firmware itself accepts the connection. That was like the old Bluetooth where you see the system dialog, and with Bluetooth LE it's the job of the application layer to say yes or no to the connection.
Maybe I'm a paranoid, but when I started to think about these things, I thought, this is not a door open that I'm leaving to my phone, and some vulnerabilities can come from this open door.
So it depends on the app that you're running. If it's a badly written app, then certainly it can be a security risk.
So in this, I'm trusting BitChat to open a proper door,
yes, but also, phones are pretty secure in the sense that the application itself is not able to do bad things if you don't allow it to, right? So there's a very strict permission system on your phone. Let's say, so the vulnerability would be, obviously, if you use an application, it could do weird things, right? But we're now speaking of vulnerabilities where you're not installing malware because you've read the code, for example, you trust the app, it's not going to send your GPS location to a server. But we're talking about the case where the app itself is exploited, so it does something that is unexpected and unexpected by the developer. And so that's always possible, that some external signal could cause a buffer overflow or some system error, or like hack the app itself, and then the app does something that it was not supposed to do. But then again, then you have the operating system kicks in and just says no if you don't have the permissions. And this is more of an issue on Android devices than on iOS. iOS is way more siloed off. The applications have fewer permissions. But today's like modern Android operating systems are getting pretty close to that as well, where you have to, for example, like BitChat cannot read all your photos, for example, because you never pressed allow access to the file system. You have to manually accept that. So even if you could exploit the app from the outside, then it still wouldn't be able to access.
You need those permissions.
Yes. So the OS makes sure of that.
Great. So this was the afraid part, these crazy things, I think.
Fair enough.
But this is great. And first of all, I was listening to your podcast with Odell, and I shared some feelings he had at the beginning when Jack Dorsey published the app. I thought like, okay, great, another mesh messaging app. Like I'm into Meshtastic as well. And I said, okay, great, now we have the Bluetooth one. But I was not expecting such a app. And the thing is that the more I think about it, I'm more excited about it, because first of all, for example, Meshtastic, you need to buy some device. They are very cheap, but you need to buy something else that you don't have. Everybody has a phone. And this is the great part of this. And then I started to get excited thinking about meetups. In all Europe, in all the world, there is plenty of Bitcoin meetups, in Spain as well. And then I started to think, oh, wait, this is great, because we just got, for example, to Bitcoin Plus. We don't know each other. We don't maybe know our Nostr identities, our names, but we can open this app and we are connected somewhere.
Yes, there's I think like there's many use cases where you just want to communicate with your surroundings in some way. It could be like sharing a link, for example. Like I just gave a talk. Imagine I would say like, okay, now follow me on Twitter, and here's my Twitter handle or link. Like the only thing that we do is pasting QR codes. That's how far we come, right? So there is no way to quickly reach the people around you. People, there's these. I love these jokes. It's like, BitChat, you're close, like the meme with the guy who's in the urinal pissing, and then there's someone approaching very, very closely, and he says like standing next to him, and he says like, "Want to BitChat?" Yeah. So why would you want to chat with someone who's close to you?
Yeah,
right?
this is the criticism. Somebody told me already. Like, why if you're on a meetup and there is that person in person in real, why would you jump to your device?
Yeah, exactly. I mean, just talk to them.
Yeah.
It's a free country, but talk to them. But there are many use cases where you need to transmit some text data. There could be just an announcement, for example, on this conference that the program has changed. How do you reach everyone without registering, right? The only thing, there are two options that I know. One is QR codes, where you need to beam a QR code somewhere and hope that people scan it. So it's like a pull way of reaching people, which is, cameras were never made for this and so on, but okay, it just works, and it can transport like this tiny payload, but it works. And the other thing is registering with a service where you just say, hey, I'm now at this conference, now I want to receive all the updates from the conference organizers, right? So we're just making this example with the conference now because it's like the situation that we're in. But this way, you don't have to announce yourself, we don't have to register anywhere, and you don't have to be like looking at the same thing to scan a QR code. I can kind of be pretty confident that whoever is on this conference ground and who has BitChat open is probably reachable right now. Whoever wants to be reached can be reached right now. So
yeah, I'm gonna keep on sending messages.
Yeah.
But I think that we're in this phase of figuring out new use cases. But this what you just said, like it could be a notification app for an event you are attending, and you don't need to provide your email, register in any website to maybe there is a change of plans, maybe that talk is not happening anymore. So yeah, you can get that information in this kind of app. It goes to sleep, no? After a while, or how is in the background? It keeps on receiving information once you open, or how does it work?
I'm
gonna be plugging my I'm gonna plug my computer.
So I don't exactly know how it works on the iOS side because, well, iOS is probably a lot stricter on background activity than Android is. And I didn't build the iOS app, so I don't really know exactly how it behaves on the background. I'm pretty sure there is some way for iOS apps also to do something on the background. But I don't know how that interferes with Bluetooth. That being said, for the Android app, it just keeps on running in the background as long as your OS doesn't kill it. But then there is also the concept of foreground activity in Android that is not implemented yet, but there is a PR open from someone on GitHub who opened the PR to add foreground activity to BitChat Android. That way, if you disable battery optimization, it will ask you when you start it for the first time, do you want to disable battery optimization? So that gives your app at least like more time on the CPU if you close it. And with a foreground service on iOS, on Android, you can pretty much get like infinite resources if you like.
Okay.
So then we just need to make sure on the BitChat app side that the battery drain is acceptable and doesn't use too much battery. But so it doesn't really do much in the background. If there is not much happening, it's just like doing these Bluetooth scans, and the BLE, the LE means low energy. So it is highly optimized. This is something that uses really tiny amount of battery. You can that's why this Find My devices by Apple, they just last 2 years or something with the battery, because Bluetooth low energy is pretty good at conserving energy, and the range is also limited. So the power that the radio sends is truly small. And that ties back also to what you said in the beginning, where you thought like this already exists in some form, right? So I don't think it's good to compare it to Meshtastic, because I love Meshtastic, but it's other, like you need additional hardware for it. So ESP32 or something.
And knowledge, because you cannot just start. You need a bit of knowledge,
Yes.
even if it's a 10-15 minutes crash course, but you need something.
Correct. Yeah. So you could also buy these kits that are soldered for you, but at least it's not on your phone that everyone has one, and but there has been also apps that do this, called FireChat, for example. And FireChat also has been used in political circumstances in Hong Kong in 2019, where the protesters couldn't use the internet because the regime turned off the internet. So they used FireChat on the ground to organize the protest. It's like saying, hey, this is a dangerous place, this is a safe place, we are moving to the left now after the square. So the mesh communication was important already in cases where the internet is not accessible or unsafe to use. But what I wanted to say here is that the technology has changed since then as well. So that also explains kind of the a renewed excitement about this, I think, because the chips are so much better now. Like the phones are so much better, the hardware, the energy use is so much smaller. So it gives like kind of a new opportunity to try it out again. And so that's what we're doing.
No, and also it puts back the conversation on the table about these parallel infrastructures that we can all build or use. And I don't know, I love how it makes my brain work, thinking about possibilities. For example, now, just listening to you, I was thinking, okay, but maybe I want a way to tell my phone, of course, don't go to sleep, keep this app running, and I want to have kind of a beacon. So I want a message to keep on repeating every 10 minutes or every 5 and saying, hey, I'm here. If you see this message, maybe access this website so that you saw it. Or, for example, you just texted something before saying, like, there's a proof of concept. If someone reads this, come to the live desk. So imagine this if you could program it, no? Or and as the beacon feature, and with some limits to not spam, but at the end this is open. If someone hacks it, can spam it. This is also another problem. No, people can use this tool in the wrong way. It can try to spam you. And for example, I remember in LabitConf 2 years ago, somebody went there with this. How is this tool called? This hacking tool.
IMSI catcher or
no?
It's
I don't remember now. There is a white and orange Flipper Zero.
Yeah, the Flipper Zero.
And
cool.
He was like switching on all the iPhones or making to all the people in the conference was feeling that they were connecting AirPods to the iPhone, and there were no AirPods.
That's Bluetooth Low Energy right there.
So this thing can be easily disrupted. So also it's a challenge if someone wants to make
100%. So it's an open system, right? So we have the same problem like with any anonymous system is you don't need to register. That means anyone can join and it's easy to spam it. So we need to kind of, when it's time to fight this problem, we need to like approach it somehow.
Yeah.
At this point, it's not there yet. Where like no one has started spamming. I know that people have already built like spammers that can, generate an infinite number of users and just spam the chat with like lots of fake users or fake messages and so on. So, but the nice thing about this is hyper localized. So even if you spam here, it's not going to affect anyone somewhere else.
It's like a person screaming in a room.
It's like a person screaming. It's a very good way to compare it. So yes, it's easier to exploit in a sense. But there's also, by the way, so I want to mention this. There's also an end-to-end encrypted direct message feature here.
Look, we got somebody, Hernan came because of the...
So you cannot see it, but someone approached us at the live desk because we just announced on BitChat that...
Did you read the message?
No.
No, you just... No, so he didn't read that.
Okay, so but we still see your message.
A fake positive.
A fake positive, yes. We're just asking around if someone wants to come, who reads the message, come to the live desk, and you just came right after and wrote hi, and now you're here. So,
you want to join? Free to join us.
Oh, of course.
Yeah, I think the possibilities are huge, and I really look forward to see what communities can think of, because I believe they are the ones that will find some use cases with BitChat. But I want to jump fast to Cashew. Here you are in a very good place, because here there is a lot of talks about Cashew that are not done by you, which is normally everything around Cashew is Calais. But here, no. Here, we
not anymore.
Not anymore.
That was the plan. Decentralize.
Yeah. And we have more and more talks. Before I was talking with Eric.
The best designer in the Bitcoin space.
Amazing conversation. And then also I was talking with Arjen about Tollgate, and he was mentioning, and we are going to be using eCash to start paying. And Kalle, we spoke, I think that it was the first podcast that you did, no?
Absolutely. It was 2 weeks after I came up with it, we spoke, yes.
Yeah.
Because you were researching Charmin eCash.
Yes.
Independently.
Exactly.
Yeah.
And then even we were sharing some screenshots, that because I was really into finding the screenshots of back in the day. There is not many, but I found some.
Of the old DigiCash wallet.
Exactly.
Yeah.
So, and I was really excited, because I was also investigating Fedimin then, and it was still not out, but you made me possible to experience eCash with it was a command line program by then.
Yes, it was all command line interface.
Exactly, but it felt
That's
amazing.
how everything beautiful starts with an ugly command line interface.
Yeah. It's only that when you are a normal user, you don't appreciate it. But
look, I just want to I hugely appreciate what you say, and just want to make clear is, although I started to roll this ball, obviously, but so many people, really, really good programmers and hackers have joined the project. So, like, most of the stuff that is happening is not me, it's others who have put so much effort and ingenuity into designing, like talking about Cashew TS, the TypeScript library that is used in dozens of wallets to integrate Cashew, from like pure Cashew wallets to wallets like Zeus, the non-custodial Lightning wallet that added Cashew as well as a custodial option. And then we have CDK, the Cashew development kit written in Rust, which is a super stable, easy to use library for and standalone wallet and Mint. So it's kind of a entire package written in Rust to do Cashew things in other applications. We just recently started implementing this also into wallets. It makes it like stupidly simple to add Cashew to stuff. So there are many people who have joined, like really good developers. SimpleKit, Ege, we have Tom, Lolofirst, like more and more people I should forget to mention here. But you should really check out their work and talk to them. They're incredible guys who've putting a lot of energy into it. So I'm just extremely happy and lucky that I found support from these people, and we're looking for more people who want to join. This is nothing that an individual can do. I don't believe that an individual can really achieve meaningful scale in terms of changing things. You need to find support. You need to find exchange. You need establish a culture around the project, and that's that's what more and more my role is shifting towards, is to make sure that others can contribute and participate.
That's great. I was talking. I really enjoyed the conversation I had with Eric before, because I said why Cashew when, come on, we're Bitcoiners. This is against our values. This is against our ethos. Come on, but it's not good. But it's not Bitcoin, no? The kind of sentence that.
Yes.
Yes, exactly. That's it's not Bitcoin, and that's the good part. But he told me some examples of why it's interesting, because it's interesting when you're on Nostr, you see more and more people excited about Cashew, but also you see more and more developers excited about Cashew, which is the noise starts to be so loud that you cannot look to another side. It's there. And I was asking him, like, why do you think is that? No, maybe for a Bitcoiner that it really still doesn't want to check anything about Cashew because it's custodial. Come on. And he gave me one example that that is probably so obvious, but it's true that with Lightning and Bitcoin, whenever you want to pay someone, if we're not including Bolt 12 and if we're not including Lightning addresses, you need a communication. No? So you need to ask for something. Give me an address or give me an invoice. And here with Cashew, it's like, no, you can just throw the money to the face of someone and say, no, take it. Yeah, I like your content. Take it. Claim it whenever you want, you know?
Sure, for the receiver, it doesn't matter. Like, you can just melt it to your non-custodial Lightning wallet. You don't have to buy into Cashew. It's just you take the eCash and melt it to your Lightning wallet.
And this is something that I saw because anybody can be a mint. So I can be a mint on my Lightning node and just use it not as a community mint. No. Just for when I want to do, for example, Hernan is a core contributor and I want to thank him. And then I say, okay, look, here you are. It's from my mint.
Anonymous gift cards from Luna's node.
Exactly. And he doesn't need to trust me because, as you said, he can claim it directly to Lightning.
Sure, like, I really, like, this is all about freedom of choice. So, multiple things.
Go for it.
First of all, we're interested in privacy, right? There are so many Bitcoiners who use custodial systems, right? If you decide you don't care about them, that's fine. Like, I do care about them. Like, I want to improve their situation. So from that perspective, I only see like a net positive because we're not making people use custodial systems. The reason why people use custodial systems is because Bitcoin does not scale in that direction yet. It's not as easy to use Bitcoin in the correct way as many, many people require. Whether you like this or not, it doesn't change a thing, right? It doesn't change a thing. And then, like, there are many people who think this alone is worth improving their situation. The second thing is that like, there are more and more developers interested in this, but none of them like stop working on something, you know, non-custodial or something, and then decide to go over to eCash development. It's the contrary. It's like developers who have never contributed to Bitcoin before, they enter the space through contributing to Cashew. So we are minting new Bitcoin developers through that because we're giving just more people different ways to participate in the system. So because Cashew is a protocol and we heavily focus on library development, that means it is one of the ways how you can get started building Bitcoin-based applications. And it makes it extremely easy to bootstrap an app that uses Bitcoin, right? And like, this just increases the number of applications that support Bitcoin, increases the number of Bitcoin developers that come from the fiat development world into the Bitcoin development world. And I think like it's a net positive for the entire space if we can get more diverse set of people coming into the space and start contributing. So that's how I see it. I think there's a lot of benefit for the individual users and also for the space itself. And one last thing I want to say is, like, I'm super excited about a project called Hashpool. So right now, I keep saying this, and I also strongly believe in this. It's like eCash was around 25 years before Bitcoin. It's an ancient technology. It was super clunky and useless before that because no one has built an eCash system on scale before Bitcoin. Because which bank is going to cooperate with you on that, right? So that was the biggest issue, was you need to go through the entire fiat hellhole first in order to build an eCash system that people could have used, which no one did. So eCash itself is only interesting because we have an underlying neutral system behind it, the Bitcoin system, where you can just put a system like Bitcoin, like an eCash mint on top of it and just start using it. But we're now also starting to see like a direct effect back, and I'm so bullish on a project like Hashpool, where you have Bitcoin mining as one of the foundational parts of Bitcoin, which hasn't seen much innovation for a long time except for Stratum, where every Bitcoin pool, it's so prevalent we forgot about this fact, is that every Bitcoin pool is a custodial system, and we never really started to improve those Bitcoin pools in terms of privacy, for example. So now Hashpool is a project where they design a Bitcoin mining pool from ground up with new properties using eCash. So it's the first time where Cashew can kind of contribute back to the Bitcoin system directly, without just what I said, increasing the number of developers or increasing the number of users, but like really change something inside Bitcoin itself, which is like unexpected and beautiful to observe.
And it makes full sense because the pools are custodial in the way that they don't pay you out directly from the Coinbase transaction, because I believe that there is some problem.
Ocean is doing that, but it's a tiny number of miners get that, because it's basic math. It doesn't work.
And the problem of of course, that if you're gonna earn few sats, maybe you're gonna be below the dust limit.
And how many, like, even if you earn more than a few sats, how many payouts will be? Could you put in one single Coinbase transaction?
So
it's not much.
So again, if we have custodial wallets and non-custodial wallets, we have the most majority of pools are custodial. So they earn the rewards and then they split however they want based on your work. And
the number is much higher than wallet users. The vast majority of miners are custodial. It's like almost nobody mines non-custodially, basically.
So in this way, you could make a better pool because you can provide privacy.
Exactly, and you can verify the pool, whether the pool is behaving correctly or not, whether the pool is eating your shares and not telling you that they are screwing you on the back, because Cashew tokens are verifiable, and the pool can issue the proof of liability scheme. The proof of liability scheme that we have, in which like a mint could. This is not live anywhere, but we have like this, at least theoretical construct, where the mint can prove that the liabilities that it issued are not greater than the reserves that it has. The same system, the same idea can be used for a mining pool to prove that the amount of hash rate that they have received equals the number of eCash tokens that they have issued later. So it's verifiable and it's private, and also it allows you to trade these shares like a future instrument. Like I don't know if we will see this happen. It's certainly an interesting idea where you could, even before the shares mature, basically, you put hash rate in, you get like a promise back, and then this can turn into a Satoshi if you find the block. But there's a risk associated with that token, right? Because it could also happen that it never turns into a Satoshi if the pool doesn't find the block. But you can kind of get rid of that risk if you sell that share before it matures. So there's a new type of market possible with these tradable e-hash tokens, which they call it.
I was talking yesterday with Mikita about this bit credit that they are building and how they use eCash tokens to issue bills of exchange, and I'm really interested in that because I was always thinking I'm really into Bitcoin loans, and for me sometimes my short-term liquidity I keep on lending it out to gain some interest. And then sometimes I think, but why what if I want to claim it before the year? It would be amazing to be able to sell that loan to someone else and accept that I will lose some part of the interest, but sell it already. And I think that there is a lot to explore here, but eCash tokens in general can help here. Not Cashew as with Bitcoin denominated, in this case is another kind of instrument. But it's amazing. And this technology, as you said, it was very old.
Very old and independent of Bitcoin. It's just something completely different than all the other blockchain technologies that came behind. So it just makes sense to reuse it on top of Bitcoin.
I have two questions before I let you go and be free.
I'm free, man. Don't worry. I'm free.
First is, I did when we recorded, I did my full research. I get to understand blinded signatures, and it's been a while now. But sometimes I get this thought or this question that have you maybe, or maybe not you, or somebody in the community really check if the mint can track somehow users using Cashew? Or is there some privacy concern, some, I don't know, some kind of attack that you found, or no, or were fully, as we believe, really private using eCash?
Yeah, multiple things come to mind. So first of all, I think the biggest Achilles heel of these systems is network level privacy, which is something that Cashew cannot solve. It is your IP address. You come with one IP address, you come back with the same IP address, it's probably you or everyone in your Wi-Fi, right?
Yeah.
So that's an issue that the underlying protocol, that the financial protocol on top of the network protocol cannot solve. It needs to be solved on the network level. So I think we need to work a lot more as a, that's not even Bitcoin. It's like as our technical community basically work on alternatives, and that's why things like Tor
The same
are
problems
so
with Lightning
important.
and Claudia. I was talking about it the other day.
Yes.
Like all these network threads. Yeah.
So, but there are one mitigation that is directly applicable that people have been doing already is using Nostr for it.
Okay.
So we can also communicate with the Mint using Nostr, using something called Nostr Web Services, where you can just emulate the HTTP interface using a Nostr interface. So instead of me talking to you directly, you're the Mint, I'm the user. Instead of me talking to you directly, I just post a message on Nostr and you get the messages on Nostr.
So is the
now
relay?
there is only the relay knows basically that I'm connecting to it, but the relay cannot read my messages because it's encrypted to you. So the relay might know that there is an interaction between the two public keys.
It's kind of like Nostr Wallet Connect in a way.
Yes, similar to Nostr Wallet Connect, where also the service doesn't have direct access to your computer. So you can use Nostr as a hop to hide your mask or IP address, which I think is pretty good already. And it works kind of well also with like a protocol like Cashew, where the interaction with the Mint is very limited.
Okay.
So there's the network level interaction. And then different transports like Tor can improve that, but that's hard to implement into systems. Having Tor on your computer is something that only hardcore nerds do, and so having it on a phone is very uncommon and so on.
Maybe a VPN.
VPN is something that everyone can do and everyone should do. So that's like the most go-to thing, is always use VPN for anything that you do, especially if you use Nostr, only use it with VPNs. You should really get a VPN if you don't have it now. Get a VPN. Mulvat now accepts Lightning. So there's no reason to not use a VPN. And don't turn it off. Just turn it on all the time.
Yeah.
It's like safer sex. You don't turn off the condom just sometimes. You just use it all the time until you find your partner for life or something. But use it all the time. There's no reason to turn it off. So that's the network level. And then there is like one theoretical issue as well with denominations in Cashew. So we have already like buckets of denominations, 1, 2, 4 sets, 8 sets, 30, like 16, 32. We have a limited number of Cashew denominations, because if you had every denomination on a continuous scale, then you could, like, let's say you mint like 1337 eCash sets, and then you come back later and you use that again with the Mint. The Mint kind of knows like, it's the same guy, like, because it's a very special number. He minted 42069, and then he came back.
Yeah.
Right. So it's easy to connect the two, and the more unique that number is, the easier to connect you.
Yeah.
That's why we have these buckets. But even the buckets are not ideal. So the buckets also reveal some information about you. So first of all, some buckets are more rare than others, especially like very large numbers. If you mint like one big fat coin.
Which is the biggest bucket?
1 Satoshi.
No, the biggest.
Like in terms of number of people?
No, the biggest bucket in the nomination. So we have 1, 2, 4, 8. No?
10 to the power of 64 is the configuration in most Cashew mints, but the Bitcoin supply is 10 to the power of 54 or something.
Okay.
So we don't use the entire range anyway. No. But even like you're not going to mint like the entire Bitcoin supply in one eCash token. So
yes.
It goes arbitrarily high.
So
that's the answer.
Okay.
Arbitrarily high. You could limit it artificially at some. There's no problem to limit it artificially, but you just have to make a trade-off between what's a good balance, what's not a good balance.
What's
and
the bad part of limiting? Like, imagine that we would limit to 128 sats.
Yeah, the
length of the token.
Yes. So the efficiency is what you trade off. Again, like with privacy and efficiency is always the same trade-off. is your wallet becomes larger, you have to manage more coins, and because you are interacting with more coins, then you also pay more fees to the mint, because the mint also needs to do double spend check on all the coins that have ever been spent.
So more work.
So there's a database of the mint that grows faster, because there are more tokens, like the number of tokens is higher. But that's fees. I mean, you could just tell the users, like, that's going to, instead of 1 Satoshi fee, you have now 2 Satoshi fee for many transactions. You could have that.
Because we have these small buckets and you are more private here.
Yes, you're more private, but it takes more disk space to store all the eCash, so you pay more. That is one way of approaching the problem. Practically speaking, this is not an issue right now that makes me like weary and we need to solve it right away. Instead, we're kind of thinking more long-term of how to approach this, and there's one really good way to approach this, and that's why we like focus more on, is amount-blinded eCash. That's like the next evolution of Cashew. That is going to, it's so much work. It's a lot of work, but here a lot of first, Tom, one of our like most like best developers that we have in Cashew, he has already written an implementation of this. It works with something called KVAC. KVAC is an anonymous credential system that is used in Wabi-Sabi, in the CoinJoin protocol of Wabi-Sabi. They use it too.
Mm-hmm.
It comes originally from the Signal protocol, where it is used to hide group membership and admin membership and so on. But essentially, like, so how it works in Cashew is it allows you, I will make another like connection so people can imagine. It's very similar to how confidential transactions on Liquid work, or how Monero works as well, which is all to say that's amount blinding. And amount blinding is a way where you can make a transaction on Liquid, a confidential transaction, but it's also the same in Cashew. You can make a transaction with the mint where you have like eCash coming in and eCash going out. But instead of telling the mint what the amounts are in the entire transaction, you just prove zero knowledge that the inputs equals the outputs. So the inputs minus outputs equals 0.
Yeah.
And that's all the mint needs to know. The mint just needs to know that you're not producing eCash out of thin air, basically. And that way you can make a transaction where the mint doesn't see the amounts. And why is that now? Why is that good, or what does it help us? Is now with this we can finally get rid of the buckets. We can now, with amount-blinded eCash, we can have eCash tokens with any arbitrary amount. It can be any specific, precise amount that you want.
But it's blinded.
But it's blinded, so the mint doesn't see the amount.
So the mint knows the balance because it has some kind of general commitment with zero knowledge proof, but cannot know what is. But then wouldn't the mint know when a specific amount leaves the mint?
Correct. So the mint just needs to know the amounts getting in and coming out. So you pay with Lightning anyway, for example. But the amounts are visible.
But the correlation attack, then it would be possible.
Only if you have like a, so it's how it also works in Liquid, right? For example, if you create a Liquid Bitcoin, then you just send Bitcoin to the functionaries, and they see the amount of Bitcoin that you put. They must see the amount of Bitcoin. There is no other way. And so they see the amount of Bitcoin, and then you're inside the system, and then inside the system you hide the amounts, and then when you go out, you must show the amount again.
Yes.
When you go out, you must show it.
Yeah, you shouldn't get out with the same amount. You
should wait a bit until you get out, so you should put a delay in between those two operations so other people can join and exit in the meantime, so that increases your anon set.
Yeah.
But most importantly, inside the system, you can do like amount-blinded transactions. But what this helps with for Cashew is now you have even better privacy than before, even better. But even, I think, more importantly is that you have even better efficiency than in the system from before. Like this balance between privacy and efficiency is like flipped over. You have maximum efficiency and maximum privacy, which is why this is so beautiful. Is with the amount-blinded eCash, we can encode your entire balance into a single token.
Maybe some more work for the mint that has now to deal with zero-knowledge proofs and so on, or not really?
CPU. I mean, CPU is you just compute and you ask for a tiny amount of fee and you're done. Yeah. It's really like, it's kind of insignificant because it's a couple of elliptic curve operations and you're done. So, but on the wallet side, it's amazing. So the wallet has more work to do. The wallet CPU has more work to do. It produces the zero knowledge proofs and the range proof. The range proof is the big fat one that really takes CPU cycles. But I mean, who cares? It's just it's like a phone. It's not the mint.
Yeah.
It scales forever because you can just get a new phone and more phones.
Yep.
So the mint is not the bottleneck. So it scales nicely, but even nicer is that the wallet itself can keep the entire balance in one single coin, and the size of the wallet, in terms of size, remains constant.
Okay.
So you have let's say you have 1 kilobyte of storage on your wallet, and your entire balance is always only 1 kilobyte. So when you receive, what you do is you take the new coins and you merge it with your old coins, then you have still 1 coin. And when you want to pay, then you slice off some part from your coin and send off the sliced amount, and you keep the rest again in single coin. So your wallet always remains single size, and that means when I hear this, it means for me is this is perfect for the web. Now we can now store the eCash somewhere else. We can do end-to-end encrypted storage. We can store it on a Nostr relay. We can store it on some backend, because the size requirement doesn't change over time. I can just tell you, hey, you're a new user. Here's 1 kilobyte of storage for you. Put your wallet in there, encrypt it as you want. I don't care about 1 kilobyte, and you can just keep on using that. And so for Nostr, so saving eCash on Nostr or saving eCash on a server end-to-end encrypted is perfect.
Really interesting.
Yep.
There are 2 questions here, so we're going to use that we're live to read them. Inigo is asking, Kale, do you see future in the non-custodial Cashew proposed yesterday?
So to clarify that, you can see also me clarifying that in the past post there. This is from Luke Charles, the CEO of Umbrel.
Yeah.
It's a super cool proposal. So I'm just going to quickly summarize what it is. Right now, we create eCash with Lightning. So you make a Lightning payment to create eCash, and then the eCash, the eCash is non-custodial, obviously. I don't say that, but for now, for all your pro viewers, they will not misunderstand me. The eCash part is non-custodial, but the Bitcoin in the mint is not in the control of the user, right? So before that, the normal way of using Cashew is you generate, let's say, 100,000 Satoshi worth of eCash, then you have it in your wallet, and then you keep using that. Because you're not running a Lightning node. So otherwise, if you ran a Lightning node, what you could do is you could generate only this little bit of eCash that you need for this millisecond. You use that, and then you're done. You're gone. Like the eCash liability is gone from you. But it requires you to be a non-custodial Lightning user, which is the original problem, why many people, don't run Lightning nodes. So what this proposal uses is a Spillman channel. It's not the Taj-Draja channel that we use in Lightning, but the Spillman channel. And the Spillman channel is the simplest form of payment channel that I can think of. It's basically like an on-chain balance that you keep updating, but it's unidirectional.
Only one.
And it's only one direction.
Only
you can
push.
you open the channel, you just push in that one direction. You cannot receive on the channel. But for an eCashment, it sounds kind of useful. So what you can do is you open a Spillman channel to the mint, and then you create eCash just like for the moment that you want to use it. For example, on Nostr, you want to make a zap. You create the eCash, send the eCash, you're out of eCash again, and the rest remains non-custodial in your Spillman channel. So, disclaimer, I didn't choose these words, and you can find me also clarifying this multiple times in the original post. It's not the eCash part is not non-custodial, but all your balance that you keep in the reserve basically can be non-custodial on a very, very simple channel construction. That means you can just easily run it on a node. You don't have on your phone, you don't have these online requirements like in Lightning. You're not involved in routing, and so because it's the most primitive form of payment channel that works.
That's great. The same Inigo also asking, can the network mesh, because now we're going back to BitChat, can the network mesh be used in big cities or just small communities?
I think it's even more useful in big cities than in small communities. So the higher the density of users, the more useful mesh becomes because of the network effect. So in a big city, in a large congregation of people, a sports stadium, concert, Bitcoin conference, those are the places where the mesh becomes more useful.
That's great. My last question, I asked the same to Eric before. what is now in August 2025 your go-to wallet for Cashew? And also, I will ask you for resources. If somebody listen to you, to Eric, and say, I would like to give it a try, what do you suggest?
So I think the wallets that I would recommend right now, which I think like all of them are pretty solid and really good wallets. For Android, I use Minibits. Minibits is amazing. It's my primary Zap wallet. The Nostr Wallet Connect works really, really well. So I use that on my Android. On iOS, I really like Macadamia. Macadamia is in Swift native.
Eric said
wallet.
the same choices.
It's really good wallets. Like Macadamia looks amazing, feels like iOS. And for the web, Cashew.me. Cashew.me is a progressive web app, and in the web browser, you can just install it, like add to a home screen on your phone. That's the wallet that I use the most, to be honest. So it feels like an app on Android and on iOS. It works on both. You have to go to Cashew.me, then it opens the wallet, then you go to add to home screen. On Android, you have to do something else than on iOS, but it tells you what to do. And then it looks like an app. It's on your home screen and you can just use it as an app. The nice thing about it is no app store. You don't need an app store for it, not even on iOS. It's just like a web app that feels like an app on your home screen. So you can check that. And for resources, the best place is cashew.space. That's our main landing page. You will find links there for all the other resources. We have a documentation at docs.cashew.space where you find wallets, tutorials, interviews, and articles for resources. It's a great way to just learn. You can join our Matrix server if you're a developer. Like all the development talk that we have happens mostly on Matrix. And we have like different channels for the different projects. We have projects in Rust, Python, TypeScript, Golang, several different languages that if you're good at one of these languages, you can just start rolling with Cashew. In these days, there's vibe coding, so basically if you can do English, you can do anything. So definitely check it out. Otherwise, you can find me all on the socials. I shitpost all day, so you will find me. Just write me and DM me. If you're a developer, like please, I'll show you around. If you're interested, we appreciate anyone who wants to look into it and join. There are many, like my thanks goes to the organizations that support the Cashew developers. There are like many different organizations like OpenSets and HRF and Spiral and others, and that support Cashew developers. So if you're interested, if you're a good dev, if you want to join, there's also opportunities for you. And together we want to improve Bitcoin. That's our main focus, is Bitcoin and privacy for users. And if you are not interested in Cashew, then you should just join Bitcoin as a developer. I'm pretty sure there are developers out there who think I should change my life and I don't like this corporate job and it feels useless and senseless and I don't know why I'm sitting here in this office. Guess what? You don't need to do what you're doing. There is a whole community that needs your help, and we can really use anyone who can help us improve the software that we're building and reach more people and help more people to get off the fiat standard and come into Bitcoin. So please join us.
That's a perfect closing, and another question came to me, but I don't know if I want to say it because it was perfect. But I will say it nevertheless because it's a practical one. When you have a lot of eCash tokens in different mints, and you can see you have a 100,000 sats, but 20 is here, 30 is here, and so on. Do you stress? Do you want to join them, or not at all? You just accept it.
It's the good part about it is that you do not need to centralize at one custodian, because that increases your risk of getting rugged and losing your entire balance. So the nice part about it is that you can use any of the wallets that I just said. They all support multiple mints. So you can just put 5,000 sats here, 10,000 sats there, 50,000 sats there, depending on who do you trust how much, and who did where did you receive the money, and so on. So what I do is I separate it. I spread it out across many different mints, smaller balances, like pocket change on every mint.
Change, yeah.
And so this was like some of a challenge for UX before, because now you want to pay a Lightning invoice that is larger than any of the mint amounts that you have. But we have hacked the Lightning network, and we have come up with something we call multi-nut payments. It's called multi-nut payments because it uses multipath payments in Lightning, abuses multipath payments in Lightning. I don't know if you know about this, but it's so Can I explain this?
Please.
Do we have time for this?
Yeah, of course.
So
All day.
multipath payments in Lightning, we are using this all the time already. If you use LND and so on, it uses multipath payments, CLN as well, and Phoenix as well. So multipath payments was designed to increase your success rate by paying from one node to one other node by multiple paths. So the payment does like goes like spreads apart, takes multiple roads, and then is joined at the end again to a single payment, and then you clear the payment here at the end, and then it propagates.
It was what was this created because to be able to mix different balances you have in different channels? No.
No, it does. It also works without that. So you can just
you only have one
exit
channel.
single channel, and then it spreads from there as well. So it doesn't matter where you spread. You can also spread right away. But it wasn't really meant for the channel management at the source, but rather there's just like probabilistically the chance of reaching your destination increases if the payments are small.
Understand.
So it's like a shotgun technique, right?
Yeah.
So like a shotgun, if you shoot with a shotgun, the chance of hitting the target is just higher because like you do this, you spread it out. So, but it was always meant to come from a single barrel, single shotgun shooting many projectiles, right? So what we did is, like first, if you look at the protocol, that's what we, you know this about Lightning. The source is anonymous in Lightning. You can make a payment to a destination, and in the invoice it says where the payment goes, but the destination doesn't know where the source is. It doesn't need to tell who sent the payment. That also means that there is no requirement to send a single payment from one single source. So in multi-node payment, we kind of abuse the MPP feature of Lightning by taking a single invoice. Like you can generate an invoice with like LND at one service provider for 100,000 Satoshis, one single invoice. And now I can put it into my Cashew wallet. Cashew.me supports this already, but the others are also working on this. Is you put this one invoice in my wallet, and then I can choose multiple mints to pay the single invoice from. So when we before had this UX challenge of separating your balances across different mints, and you have to now reconcile it and put it together to make one big payment, we don't need to do this anymore. If the mint supports MPP, which is CLN and LND support this, if the mint runs CLN or LND or LDK, then you can pay like
basically
one portion.
Aside of Phoenix, is basically all implementations.
Yes, yeah, all implementations support this. So you can pay like only the one part of the payment. So we have 100,000 Satoshi worth invoice, and I can tell one mint pay 10,000 sats, the other one pay 25,000 sats, and then like 50,000 here, and then another 15 here. And then all of the mints, they make a partial payment from multiple sources, and then they converge all at the source. And the source doesn't care, because the source doesn't even know that it's happening. The source just sees partial HTLCs coming in.
Okay.
And then the source says, okay, now I have 100,000 sets worth of HTLCs. Here are the pre-images, propagates backwards and reaches the multiple mints at the same time.
Beautiful.
So what you see is like imagine you have like multiple bank accounts, and you can pay one invoice with multiple bank accounts at once, and it's atomic. It's like either all of them succeed or none of them succeed. So that UX challenge of having to separate, for risk reasons, having to separate your balance and keeping smaller balance across different mints, now we could kind of make use of it. With a hack on Lightning, can actually make it super useful.
Great. So you're not concerned, you're not worried, you accept this.
No, I see it's one of the best features. I mean, like I'm not locked in. I can choose like how many and whoever I want to use as a eCash mint, basically. So that's for sure a feature. And on the other side, another feature is, I told you all of these wallets that you can choose and try to check it out if you like it. But if you don't like it, just use a different wallet. Since it's a protocol, it really doesn't, like there are many to choose from. You're never locked in. You're in full control. Like if you like this wallet because it looks nice, just use that. And if you're bored of it, you can just throw it away and use a different wallet with the same mints if you like. Because it's an open protocol. Everything just plugs into everything.
Thank you, Kalle. It was an amazing conversation as always. But really, I enjoyed this part of calling people who is really done with the corporate life, or is looking maybe there is young people starting now. I received a DM yesterday of somebody saying, "Oh, in what would you focus in Bitcoin now?" I mean, the answer, I believe, it's in whatever you're interested in. Doesn't
Yes.
matter if it's successful topic on Bitcoin or not, but if you're really into that, go for it. Follow your passion on that. But yeah, eCash is a hot field, I would say, like a hot topic, and it's I can say, because I'm not going to many developer conferences, that a lot of people is excited about eCash. So
It's great to hear.
yeah,
Yeah.
can be
Use
great.
the software that you're using and try to fix it. Like whatever interests you the most, just follow your interests and keep doing that. Just keep playing around and stick at it, and good things will come to you.
Kale, thank you. I'm gonna go catch Jeff because he's avoiding me, and I don't like that. I'm gonna make him some white noise.
All right. Let's make some white
Yeah.
noise.
Thank
you.
Okay, 1 minute, and I'll try to bring the last guest of the day. I think we can call it a day after that. But yeah, what a great conversation with Kale, and what a... Oh, I mean, and Kale is helping me. Yeah, Jeff, you should be here. It's been more than 20 minutes. No, so yeah, great energy as usual with Kale. Again, eCash, Cashew, you can give it a try with few sats. You can get to learn how it works. It's custodial. You are not in control of your sats, so just don't, or use it accordingly. But as Kale said, you can always claim it back to Lightning and then keep control of it.
Yeah, ready?
Please.
Let's do this.
Let's move this out to be more comfortable. Here you are.
Let's go.
So, you're gonna be my last guest.
Ooh, saved last for best.
Yes.
The best for last.
Yes.
If I can get the words correct.
Yeah. We have been meeting now for a while. I don't know. I suppose when the whole Noster.
I can't remember when we met. It's definitely a few years ago, though.
Yes.
Yeah.
Maybe.
It could have been in Riga 2 years ago. Yeah.
Maybe.
Yeah.
Yeah. It feels like that. And yeah, you have been involved in many things. Mostly Noster, I would say.
Almost entirely Noster.
Yeah. But since, I don't know, a year ago, something like that, you started to be doing most of the time one thing.
Yes.
That is
Correct.
white noise.
Yes.
Okay. White noise is out now. It's an application we will talk about now.
Yeah.
And I really want to learn a bit more. I missed your talk yesterday because I was here.
Mm-hmm.
I was only capable of listening to you for a minute or so. But okay. What is white noise and why you dedicated the last year of your life to it?
Sure. So yeah, you're right. I think when I found Noster a little over 2 years, I guess it's like 2.5 years ago now, it was still fairly early. It was very unclear.
You found Noster before Jack or after Jack?
Just after. I don't know if it was because of Jack, but it probably was.
Jack effect.
Yeah, the Jack effect.
Okay.
I was also wrapping up a startup that I was doing, my startup at the time, that we were running out of money at that point. And so I was sort of looking for the next thing. And that's when I found Noster. So it was kind of a silver lining in shutting down a company. It was like, I found the next thing I'm going to work on. But yeah, I think that first year or so was really just experimenting with lots of stuff. I think at that point, the thing that drew me to Noster was this idea that we could rebuild the internet on this new kind of weird open protocol that was doing lots of weird, interesting stuff like we were doing on the early internet. And so, you know, a lot of the projects in that point were just kind of, let's see if this would work. Let's see if this would work. What's this going to look like? And, you know, we all knew at the time, like, DMs were broken. There's nothing good about the way DMs were done. It was sort of an early hack just to see if we could make some sort of encrypted thing work. And I kept going, someone smarter than me is going to fix this problem. It's definitely not going to be me.
Can you briefly say why direct messages in Noster are broken? Because I use them, and I can talk with you if I want.
You can, and other people can see that we're talking.
Oh, okay.
That's the main issue.
What's the broken
part?
So
the NIPO for the original spec was, I mean, it's a fairly naive encryption mechanism. It does hide the content. It potentially leaks tiny bits of your private key material. There's like people have, I guess, conjectured that with enough NIPvo4 encryptions, you could sort of reconstitute a private key out of it. I don't know if that's 100% true or not, but you can definitely see all the metadata. You can see who's talking to who and when, which is bad. Then a couple of other Nostr developers worked on kind of a successor to this, which was a much better encryption scheme and a way to gift wrap messages so that you would hide the metadata of who's talking to who and when.
Okay.
So that was definitely a improvement, but it didn't give us group conversations. It didn't give us forward secrecy or post-compromise security, like things that we've come very much to expect from tools like Signal.
Okay.
So this was what people were looking for. It was like, when are we getting group messaging or direct messaging that allows us to have actual forward secrecy, post-compromise security, hides all the metadata, modern messaging. And yeah, like I was saying, I mean, I listened to lots of people talk about this. Everybody knew it was a problem. NVK was on his podcast every other week or whatever, complaining about this exact thing. And I remember, like, I was on a run and I heard it for the 10,000th time in the headphones, and I was like, fuck it, I'm gonna try and fix this. I was like, no one else seems to be doing it. I'm definitely not smart enough to like figure out cryptography, but let's just see, and we'll see what we get.
And at that moment, what was your background in
I mean,
development?
mostly like web development.
Web development.
Yeah, like mostly web development. So like the idea that I would go and do cryptography is laughable, honestly.
Okay, yeah.
And so I just started from the beginning, and I was like, okay, what has come before? How did we get to where we are with secure messaging? And I looked at Off the Record, which is like a very early protocol on how to do kind of a ratcheting mechanism. I looked at all the early Signal stuff and how Signal sort of evolved over time.
What is ratcheting? You keep on saying it,
Yes.
and you look all so smart when you mention this is the double ratchet
double
thing.
ratchet. Yeah,
You're
yeah.
like, okay, I don't
So
understand that.
A real simple way to think about it is a ratchet is just a key derivation function. So you start with one key.
Okay.
So, and
like
then you
we do
use
for
a
Bitcoin,
then
for
you-
new
sure.
addresses.
Sure.
No?
Yes, exactly. It's the exact same thing. You derive the next key using this key, using a function that does it in a recognizable way every time.
Deterministic way, no? That you
Deterministic
can.
way. It's 100% a deterministic way. So
Okay.
a key derivation function is just that. And a ratchet in a messaging scheme is just that. And the thing that Signal brought to the table was they figured out how to do using two separate chains of keys.
Okay.
So there's actually, think about it this way, there's a trunk down the middle with Signal
Yeah.
of keys. And that initial key there is agreed upon using Diffie-Hellman.
Okay.
And they call it like X3 Diffie-Hellman because they use three separate keys to do the Diffie-Hellman math so that you and I can agree upon a shared key without
Okay.
being in the same place.
Yes.
Just using each other's public keys
Yeah.
and a couple of ephemeral keys. So we end up with the shared key.
Okay.
That's the main trunk. As we start to talk, so we use that main shared key, we split, we have two kind of branches now.
That
and
come
each
from
of
the
us-
same
that come from
origin,
the same original key.
Okay.
And in those, we both create two separate chains within that.
Okay,
Each
so
of us
we-
have a sender and a receiver side.
Okay.
And my sender is your receiver, and your receiver is my sender.
Understood.
And so now we start incrementing those to actually get the message encryption keys. And so we use those keys to do message encryption, and we're rotating those keys. So that's one ratchet. We're changing those keys every message we send. And every time, I mean, this is a bit configurable, but think about it this way. Every time the conversation switches sides, so I send you 5 messages and then you send me a message, that rotates the trunk key.
Okay.
So we both know that, like, okay, at that point, boom, the trunk key rotated. We both need to regenerate our new chains.
Constantly.
And that just is constantly happening.
Okay.
And that's how you get this double ratchet of, like, one protects you going backwards, one protects you going forwards.
Okay.
And that's, where you get post-compromise and forward secrecy.
Okay, because every time that you finish a blob of information or
Yep.
a few messages, you change
You
it?
change the key, and so if somebody got one of those keys in the middle,
Okay,
so if
you-
they got a message key, they're only going to be able to decrypt that one single message that you encrypted with that key. If
But-
they get the middle key, they
Okay.
might get a string of 5 messages on your side, but nothing from the other side. You know what I mean?
And couldn't they get the root, and then out of the root...
If somebody gets the original root key, they can decrypt up until the next key. Because remember, that original root key is a derivation function itself, so you can't go backwards on that.
Okay.
And they can derive down, but then there's like I can't remember exactly what happens in Signal now. You're like stretching my brain because this was a little over a year ago. But the basic gist is you cannot go in both directions by getting different keys. If you were able to get the original shared key, there is ephemerality mixed into that, such that you're not going to be able to go in the same way. In the
it
same
will
direction.
be read
Yeah.
the first ones,
Yeah.
and that's it, and again...
Exactly.
Okay, so this is nice.
Now, you might recognize there's an issue here because we have a sender chain and a receiver chain. And so I've got my sender and receiver, you've got your sender and receiver. What happens when we want to add a third person?
Yeah.
We can't. Signal is a pairwise protocol. It means that every person in a group is having a conversation with every other person in the group separately. And so when you send a message, you're actually encrypt 5 times to 5 different people in a group.
Okay, so when I am in a group in Signal, I have this mechanism with each of them.
Exactly. And that's where Signal kind of breaks down in scaling. And because they have servers in the middle, which cost them $50 million a year,
this is a real number?
That's the real number, yeah. That's the real number.
Wow.
Cost them $50 million a year to run the service. So, this is why, I think Signal's a good actor.
Yeah.
I think Meredith is probably a great CEO. It's an American foundation, though, in an American jurisdiction with a CEO, and they have to spend $50 million a year to keep the thing running. Those are, some heavy attack vectors there. So any of those things goes down and we lose Signal. But having those servers in the middle means the Signal can do some extra wonkiness to help speed up, large groups. So they kind of fall back a little bit with some of the privacy and security guarantees to make, really large groups function faster. But in a federated environment, we don't have that ability. We're not going to run servers in the middle for you that are going to do this type of stuff for you. So if we were to use the Signal protocol to try to create groups, we would be doing pairwise encryption to every member of the group every time we wanted to send a message, which gets incredibly heavy.
Okay, here is where this is more or less the gold standard in communications for a lot of people. Signal.
Yeah.
And Signal, we are seeing this problem.
Yep.
And this Signal is using double ratchet.
Yes, they're still using the original. They're using the original Signal protocol, which was this double ratchet, plus several kind of protocols that they developed on top of it.
Improvements.
Yeah, improvements, little things that have, they've added post-quantum resistance, that sort of thing.
Okay, and you saw that in your investigation, and
I looked into that. I actually wrote a NIP, a spec for Noster that said, this is how we're going to use the Signal protocol to do messaging. And very first comment was where's groups, bro? And it was TBD in the future. And they were no, we need groups. And I was okay, scratch. It's not going to work in Signal. You were always going to have to do way, way, way too much stuff.
Yeah, because at the end we would put all this load on relays, and we know.
Yeah, it's a whole lot more messages on relays. It's a whole lot more load on the client trying to encrypt every single time. So for very large groups, it was just never going to work. You would hit an upper limit for the group size fairly quick, and that would just be the end of it.
Okay.
So that was when I found MLS. And I'd come across MLS and doing some of the research. I was this is really complicated. I'll come back to this later. But after kind of knowing that Signal wasn't going to work, it was clear that MLS was the next thing to look into.
Okay.
And the MLS spec is 160 pages long. It's an internet standard, which is really good. It was built starting in about 2017 out of research, a bunch of academics, a bunch of people in big companies.
What year you said?
They started in about 2017, 2018, on this stuff. And it wasn't until summer 2023 that it actually got accepted to the IEFT. So
it's fresh.
It's pretty fresh in terms of internet standards. Yeah, it's pretty fresh. But it's really well tested. It's fully audited. A lot of really smart people have worked on it. And
does MLS stand for something?
Message layer security.
Okay.
And it was built a little bit on the idea of how TLS works. So TLS has this handshake protocol where you signal ahead of time what features do you support or not support, and then you and the other side can define, okay, this is how we're going to talk to each other, and then we proceed.
Okay.
So there's a little bit of that in MLS.
And what does MLS bring to the table compared to double ratchet?
MLS brings scaling. So it basically takes the idea of what Signal has with the double ratchet, and it applies it in a binary tree. So it takes the group, and instead of being pairwise, it arranges all the members of the group across the bottom of a binary tree, and has keys going up back to the root on all the branches of this tree. So you have a key at your leaf, but then every node above you back to the root is also a key pair.
Okay.
And you only have to know the private keys on your root, on your path to the root.
Okay.
So this gives you some really interesting things. One is it gives you the ability to not have to rotate all the keys in a group when a group changes. It means that you only have to do...
It becomes like a Merkle tree in a way?
Sort of, yeah, sort of.
So it and it gets to a root.
Exactly. So when you add a member, you only have to add the member at the bottom of the tree.
And then construct what is missing.
And then only pass keys, a couple of keys to people rather than the entire tree worth of keys. And they, then using their couple of keys, can rebuild the entire tree, from scratch, using derivation functions again. So this gives you, it takes a linear problem to be a log problem. It turns a linear problem with signal into a log problem, so it vastly improves the scalability. The other thing that it gives you is like cryptographic guarantees of the state of the group. Because you have the whole binary tree, you know the full state of the group, you know what all the leaves in the tree are, you know who the members of the group are cryptographically. And that's actually an improvement over Signal. You're trusting Signal to be the identity service and to say that, like, yes, this is the thing. And they give you some hashes to prove bits and pieces of that, but you can't see the whole thing. And so this, in my opinion, gives us exactly what we need. And the other cool thing about MLS is it's just about the cryptographic ratcheting mechanism. It doesn't care about the identity system, about who's who, and it doesn't care about the delivery mechanism, how you're going to deliver these messages across the wire.
Okay.
And that's perfect because we use Noster's identity, public-private key pairs as our identity system, and we use Noster relays as our delivery mechanism. So this was like the perfect thing for me, right? I didn't have to do any of the cryptographic math. Someone smarter than me did that. All I had to do is figure out how do we apply this, gigabrain stuff to Noster and not leak metadata everywhere.
Okay. So we had the privacy mechanism. We found it now with MLS.
Yep.
We already have the identity layer with Noster and the transport layer also.
Exactly.
So the work was how to
fit those things together and how to make sure we weren't leaking metadata and how to make something that was going to be usable by Noster clients, because most Noster clients are sort of we have this saying in Noster where we've got smart clients and dumb relays. The relay is just a database. It's just accepting events and answering questions about what events it has seen. The clients are a little smarter than normal, app clients, but most client developers in Noster are just sort of expecting relays to be their database at this point. They don't really think about, how they're going to cache things. Are they going to store things locally? And MLS requires you to store that content locally because it's end-to-end encrypted. You are the only holder of the actual decrypted messages. Those decrypted messages don't live anywhere else. So thinking through how are we going to build this in a way that it's easy for client developers to put together without doing it wrong and breaking the whole thing, but also still quite secure and performant.
And then we have white noise.
And then we have white noise, which is the client that we're building using the libraries that I've put together to kind of implement this NIP, this spec.
But the idea, let's say that this spec is that the Amethyst could have it running inside.
Absolutely, yeah, absolutely.
So
the spec just describes how are we going to do this. The libraries that I wrote are the implementation of that spec for Noster. And then white noise is the consumer of those libraries, so that now we've got the kind of full stack and we can say, did we build the libraries correctly? Because now we're having to use it. To build an app, and is that working well or not?
Okay, we have the app out in the wild, the first version.
Yep.
What is it, like 0.
Very early version, 0.1.2.
Okay. It works meh.
It works meh, exactly. The thing is because of how complicated MLS requires you to have these different signaling mechanisms and this sort of agreement, which is not interactive. You don't have to both be online for this to work, but you are publishing things to relays and expecting relays to give you things back. Relays can go offline. Relays can come back with data that isn't
also
up to
we
date.
have this issue with the outbox model. No, that
the outbox model is very complicated.
Different.
Exactly, it's very complicated to implement. And what we found was that Noster users that have been on Noster for a while and have loads of relay lists and have been experimenting with the outbox stuff, they almost universally have problems here. Brand new users, when you create a new account and you try that out, it almost universally works. So we've been spending the last kind of couple of weeks going through that whole relay model, trying to figure out how to improve all the little bits, trying to make sure that we're doing everything we possibly can to sort of defensively fetch the right data, fall back to defaults when we can't find stuff. So that's kind of number one issue is like we just need to make this really, really stable before we start adding any more features. But the idea is that like white noise will hopefully be the most secure messenger out there and completely censorship resistant. Like you won't be able to shut down a white noise group.
Yeah, I heard when you were working on this, and this commentary is from long ago, but I heard somebody saying like, yeah, Nostr needs the killer app, something that people will use just because it's amazing and not because it's Nostr. And they were saying, yeah, when we have what is now white noise, this is gonna be the killer app. I don't know who said that, but do you think it has a chance for non-Nostr users to say, no, I want to use that one because it's pretty good in privacy?
I think there's a really big just network effect benefit to things like messengers and community groups, or community or group apps, is that a very small number of people in a community or a group get to decide what everybody else is going to use, right? So if your community has a private chat, say you're a underground rave organizer or something, and you've got 1,000 people, and you're currently using Telegram, and you keep getting busted by the cops because the cops are obviously just watching your Telegram. You could switch over to a different product, and you would force all of those people that follow you to go to that new product. So I think, messengers are a very common, it's probably the most common app that people have and use. It is an app that has a really strong network effect. The difficulty with a lot of messengers like SimpleX or things that are starting from their own identity system is you're starting from zero with a network, and so this is a really big benefit of Nostr is we've already have this huge network of people that we've bootstrapped by ship hosting, as Matt Odell says. So we've bootstrapped our network with ship hosting, and now we can use that network to our advantage when we go into community apps or messenger apps or any other type of app.
No, and then people can discover, if they are not a Nostr user, then they can discover the beauty of Nostr and how you can move your identity here and there and not be in a walled garden.
Yeah, I mean, think about it this way. With Signal, you cannot have 2 accounts on the same Signal app ever. It's tied to a phone number in most cases. In White Noise, you can already just create as many accounts as you want, ephemeral keys, whatever you want, your real account. Just create them all side by side and have them all concurrently having different conversations with different groups of people. So it's the kind of perfect setup for journalists that want to have one throwaway account for each contact they have, or people in authoritarian regimes that are very worried about who might be listening in on their conversations. So eventually we want White Noise to be secure enough for those sorts of scenarios. It's obviously not there yet, but that's the plan.
Are you the first to be using MLS for this use case?
We're the first decentralized implementation of MLS that I know of, and that the OpenMLS folks who work on both the spec and the Rust implementation, that they know of as well. I know
Even
that
centralized also, or centralized?
there are several centralized implementations or uses of it. One of the biggest is Cisco's WebEx product. Uses MLS to do the handshake on video webinars and things. So when you join a webinar with them, they're actually using MLS under the hood to do the handshake and get you into that group.
Great. So yeah, when is coming the next version?
I was literally standing over there before I came over here to talk to you, working on a couple of bug fixes and last minute things
so
before
it's
the next little release. Yeah, so we're hopefully in the next day or two going to get a release out.
So already still in Baltic Honey Badger maybe?
Yeah, hopefully. I mean, we'll see. Like, obviously, the Android app, the Android version will be out immediately, and we'll have to wait for Apple to grace our test flight and tell users that it's there. But that's usually less than a day or so.
Okay, so I'll be waiting and looking forward.
I will let you know
to try this new version. And by the way, White Noise. When Amber?
Amber is really actually quite difficult because we're not. So we're
because of the amount of signing.
Pulling back the curtain a little bit. We're building using Flutter, but the core of White Noise is a Rust crate, and that Rust crate is talking to the Flutter app via kind of an internal API. For us to use Amber as a signer, like all of the signing happens down in the Rust layer. And there's no way with the Flutter Rust bridge right now to pass those messages down into Rust or not. So we have to figure out a way. We've been working with the Rust Nostr maintainer, Yuki, to start looking into this, and it's like something he knows, like a long feature request on his side. So he's trying to figure out how to make it work. I'm sure we'll figure something out eventually, but yeah, we'll get there as soon as we can.
Yeah, because when I tried to use White Noise, I was not using it with my And
What, you don't trust us with your INSEC?
I don't trust even my phone, you know. So it's
That's
like
fair, that's
I
fair.
want to just keep it in the.
Although, in fairness, we are both, Amber and White Noise are both using the secure enclave on your phone to store the key.
Yeah.
So, like, whether you put it in White Noise or you put it in Amber, it's in the same type of storage in your phone.
Okay, good to know.
Yeah.
Maybe we'll try. I don't know. We'll see.
I mean, that's okay. You can just create throwaway accounts for a while.
Yeah,
and
this is
play
what
with
I
it.
wanted to.
This is the easy thing.
To
So.
do. Jeff, thank you very much for coming and explaining White Noise. I hope more people will be waiting for this new release and testing it. I suppose this is also something very needed to test it and,
Absolutely.
and report.
Send us lots of feedback.
Yes. So, but yeah, really excited that we're living this moment. And
Me too.
I'll be texting you through White Noise soon.
I hope so. Very, very soon.
Yeah,
All right.
thank
Thanks,
you.
man. Take care.
Take care. Okay, so come, let's wrap it up. Let's wrap it up. Now, the one and only. How are you?
Good, I'm doing great.
Yeah?
Get camera ready. Good.
How what's happening now?
Hey Luna, what's happening now? I think we're on snack break,
Okay.
but today's been a day full of, what have we been doing today? I should know. Today's been a day of talks, workshops. We had a panel, great panel with some privacy people earlier,
Yeah.
which went out on the live stream. I managed to catch some of that. We did hackathon finals happen, so we don't know who won yet. That'll
Not
be
yet?
announced
Okay.
at the closing.
Yeah.
Yeah, so that's gonna be an exciting one.
Yeah.
Yeah, it's been a really good day of I think people hanging out, making new friends, new connections. Yeah,
Great.
yeah.
No, it's and I love it. I really enjoyed being here in the live desk and how this with this Bitcoin Plus Plus conference you find a topic, no, and they are specific now with
Yeah,
privacy.
we find topics.
Which are the next one, by the way?
So we've got 3 more events this year. We've got
Why not?
yeah, why not? Istanbul next month, so that's going to be happening in I think 3 weeks in Istanbul. We'll be talking about scaling Bitcoin, so that's ZK rollups. We'll have some ARC people there talking about ARC stuff. Trying to think if there's going to be anything. I'm really hoping to have a good conversation about zero knowledge proof stuff is my hope. So we've got some good talks on ZK topics coming. So that's next month. After that, we'll be in Berlin in October talking about Lightning. So we're doing a Lightning conference reboot in Berlin. The first Lightning conference happened in 2019. We're doing another conference. We're doing a Lightning themed one, first Lightning themed one for Bitcoin Plus Plus in Berlin 6 years later. So I don't think it'll be quite as big as the Lightning conference, but excited to get that crew back together again.
It was legendary. It
It
has
was-
the level of legend already, that
yeah,
conference.
it was good.
Yeah.
It got killed too early. I think COVID.
Yeah. I remember being there, but the atmosphere that
really
it
good.
felt like when sometimes people talk about the early Bitcoin conferences in 2013, like the origin, and that felt a little bit like that, but for Lightning.
Yeah, it had that feeling. Yeah, so we're doing that in October, and then it's a lot of conferences kind of in Europe. And then we'll be in Taipei in December.
Taipei.
Yeah.
Why not?
First Asia conference.
And what do you do there?
We're going to talk about sovereignty.
Oh.
So what's that turned into in terms of, yeah.
Very good.
Yeah, we're trying to match the, as much as possible, trying to match the venue to the conversation. Yeah.
It was really nice to meet you.
Oh, yeah.
Because maybe you will not get back. No.
Hopefully, yeah. Yeah, hopefully. It's a short conference, so we'll get in and out. No. But hopefully, I've invited a lot of wallet developers to come. So we're going to have people from BDK there. There's this really cool project out of more of an Australia base called FrostSnap, who's doing cool Frost stuff with multi-sigs. They'll be at the conference. Ava
because they
Chow
are releasing
said,
soon, finally.
Exactly, yeah. So they're going to be there. Ava's mentioned she wants to come, so hoping she'll come through and we can have a really good conversation about sovereignty through, wallets, holding your own keys, technology that way. Yeah. So that's the year. We'll be in Brazil in February.
So that would be the next one?
And that first one next year.
Okay,
in
Brazil.
February, we'll be in Brazil. We're going to be talking about Exploits Edition.
How far are you
Ahead.
planning ahead? Like, do you also know the next one after Brazil, or?
Yeah.
Yeah?
Well, it's like that is a little fuzzier, but we're trying to get it figured out.
Okay, so that's there.
I don't
March,
have, like,
April is the
Yes, I've got
frontier.
a candidate for April, which I don't want to quite announce yet, and then we're talking about going to Africa for May. So we do our first African conference, which would be really fun. So that's like a good one to keep on your radar, and then probably do another North America one in the summer.
Okay, so even till next time, so 1 year ahead, more or less.
I guess so, yeah.
Interesting.
At least planning it, like whether it'll happen or not is like, we'll see.
You can always change. We're gonna wrap it up here, so.
But thanks for coming. How's it been? Who did you like to? So you've been talking to people all day, yesterday and today.
Yes.
Who did you talk to? Is there anyone you talked to that you're like, wow, that was like such an amazing conversation? Did you learn anything about privacy?
I cannot pick one. That would be also not polite. But I can say I enjoyed. Speaking with Kalle is always great.
Oh, he's great.
I'm really into white noise, so speaking with Jeff also was really interesting. Tollgate, I didn't know about the project, and interesting. Also, it always happens to me when I come to more depth conferences that I see that there is a lot of people interested in Cashew, which is funny because when I go outside those conferences, I also hear a lot of hate.
Interesting. Okay.
Yeah. So here it was really nice to connect back to people working on Cashew. So meeting Eric, I didn't know Eric before, and it was a great conversation. And I really like the way he thinks and talks. So amazing. Yeah, I don't know. It's refreshing.
Yeah, I mean, I think Cashew is. I think it's interesting to hear you say this, like two different ways of having kind of interacting with it, right? Like a feeling different crowds, emotional reactions to it, because devs get really excited about it. It's such a good testament, I think, to like the user experience as a dev. I think Cashew is just really fun to build on. It's like a fun protocol. It's easy to come in. It's inspiring. People get excited about what's possible with it. Whereas, some of the resistance I'm assuming that you hear outside of it is how custodial it is, right? And people genuinely don't like the custodianship of it. So I don't know, values I think across Bitcoin I think we tend to be pretty aligned around, non-custodial is the way to go, like all these things, but at the end of the day there's also like small things, like for developers the experience of building on it is exciting, and they have all these cool ideas of ways they can use it as a protocol because of how lightweight and easy it is, and so you get to see all that excitement here with the devs, right?
Yeah, I think it's a matter of understanding the tech, and then also understanding that the Cashew developers, Cashew, I don't know, I'm missing a word here, but yeah, people working on Cashew is not asking you to put all your wealth on Cashew.
In fact, I think you would be dumb to, right? Like, don't do that, yeah.
Done. It's about this pocket money and that you can use. Something I like that Eric told me is that something that Cashew has and Lightning doesn't have and on-chain doesn't have is that you can just push a payment.
Right.
And, I like your work, Lisa. Look, here are 10,000 sats for you.
Yeah.
Take them, and if you don't take them, it's okay. I will still keep them.
Well, I mean, but this is what a centralized service gets you. This is what a custodian gets you, is that ability to transact with the custodian because the other peer isn't online, right? Peer-to-peer exchange is more difficult because to actually do a peer-to-peer transaction, there's no middleman that you can leave your message with, right? So, it's like, yeah, you do get that user experience, and this is what I mean. Like, devs get really excited about how easy it is, the experiences they're able to create, but the trade-off is, like, with a mint, the reason you can do that is because you send your request to the mint.
Yeah, but also that you can be everybody can be a mint. And something that changed in my head while talking to Eric was like, I don't need to trust Minibits mint. I can spin a mint, but I don't want to be a community mint. I just want to be a mint just because I want to push you 10,000 sats. You are not online. You're not answering my DMs now, but you will see this, and probably you will be happy to receive this. And the moment that you see this, you don't even have to trust me because you can directly claim it online from me.
Well, yeah, but then your mint is the one holding all the Bitcoin underneath, and if your mint goes offline, I can't get
but the thing is
anymore.
that this is a present from me.
I see.
So it is already coming from me. So it is, you're already trusting me because I'm the one giving it to you.
Right.
And you were not online in that moment. Of course, people will not use it like this. People will not be spinning mints just for that. But I don't know. I got interested. I like this idea that, yes, there are use cases in which make full sense. Not to say that if you are risking $100, okay, you will be sad if they rug pull you. But there are plenty of mints, and you can have $20 here, $30 there. And if it gives you a service, then you will want to use it. If it doesn't give you a service, you will claim it and have it online.
Yeah.
So up to you.
Exactly. Yeah. No, it's very exciting, and there's some really improved user experiences that you can build with it.
Yeah.
So that's definitely so there's lots of excitement about it, justifiably so, right?
Yeah. It's kind of like I wanna keep on hearing more.
I think there's lots more to hear for sure. Yeah.
Yeah. So Lisa, it was an amazing experience to be here in the live desk. I would repeat. So
great. Okay.
Keep me in mind.
Thank you for coming. Yeah. Hope to see you at the next one.
Yeah.
Good.
So let's wrap it up. Let's
Okay.
see if we find the right